So there we can, your doubt will be recorded. So I will pick every doubt and I will explain each doubt. Okay. Yeah, that is the thing I'm going to follow. So I'm just muting everyone. So please cooperate.
No, 1 minute. Could you please mute the notifications? That is disturbing us every day.
Okay, sir.
Yeah.
Can anyone tell where is that notification is turned on? So I am not able to figure out. Anyone have idea to like?
Yes, in audio and video setting, okay, there is an option WebEx Smart Audio setting.
Okay. So
Okay, you go to the notification and there is a participant action sound is there. You just uncheck those. I think only host can do this. Might be.
Yeah. Okay, received the messages. Actually, it is.
You please uncheck it. Okay, not check it.
Yeah. Basically, it is unchecked only, but still,
Okay.
yeah, it is unchecked. I hope you saw my screen, right?
No, actually, this setting is only possible when we create a meeting. Might be. I'm not sure.
Yeah, received a meeting, so it is not checked actually. It is empty.
Okay.
Yeah, means till anyone facing any notification sounds.
Only we can confirm.
Yeah, means there is no notification sounds, right?
Actually, we hear this sound when
but
anyone
no sound,
join.
but notifications are coming, sir.
Okay.
That beeps. Okay, and that someone has joined and we don't. Listen.
Yeah.
I think it worked. Might.
Yeah, for joining only, I mean I received a beam sound.
Yeah, that will be disturbing, no, sir. Every time it will pop up and we cannot concentrate on slides.
Yeah, that thing I also don't want, so I just try to stop that thing. Always. Only if you understand.
So you please proceed. We can manage it. No problem.
Yeah, okay. I hope here it is not means it is unchecked only, but still it is for me also. I'm not comfortable with the sounds.
From the drop down, you have to select unmute, sir. Say as a host, you have the option.
Yeah, I can unmute everyone. So after our discussion, then I am going to unmute and I am going to start our session. So
no. In that setting, there is a drop down like beep sound, and there is a drop down. Please check those options there.
You check select the option and the drop down, sir.
Okay, so in deep sound is there. First one is a sound option. So in there is a called the deep sound is there. So next when the deep sound is only if not viewed panel chat for first message in a thread are always. So can I give to first message in a thread? Then that will be very good. Like
yes, sir.
At least.
Even leaving you can do the same.
Okay, joining. Okay, joining. Actually, everything is unchecked and already, so there is no like. So even
if we are able to see that there is a beep sound option selected there.
Yeah, see, basically, first it is unchecked, means it is not at all selected. So even though it is not at all selected, still the sounds are coming. So that is the point.
That is the default value, sir.
Yeah. Okay. So now what?
You have to change the default value to something else and say check that.
Yeah. Okay. So is anything sound like? I'm waiting for any sounds. I just make into another sound. So how it is let
No problem, sir. You please proceed with. Anyway, we are wasting our time. We
Yeah,
will
that's
manage
what.
it.
So basically, I
Okay.
don't want to waste in between. So that's why I just
Yes.
figure out all the things in the starting. So I think it is now. It is fine. I think so. There is no sound. Someone is. Oh, it's very worst. It is worst. Yeah. Okay. Please. I am not. Means there is no proper options. So I already unchecked the received message and everything, but still I am getting the things. Okay. 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 I am read the messages from the call. Okay. Yeah. I just unchecked everything. Okay. Yeah. Okay. Uh, okay. So I hope everyone is clear. So today our session. So till now you are discussed means you learn about RNNs and LSTMs means complete RNNs and a bit about introduction about LSTM. So today we are going to start with LSTMs and bidirectional LSTMs, and then later we are going to discuss about GRUs and autoencoders. This is a theoretical concept and theoretical concepts and intuitions and how the algorithm flows and everything. So then later, after completing this, after completing understanding on this, then I'm going to show you how I solve a real-time problem called Google Brains problem called ventilator prediction system using whatever we learn in this session, like what using bidirectional LSTMs especially. So this is the code actually. So I just show you to confirm you that whatever you are today you learn, that will be directly hands-on. Okay. Wait for a minute. Uh, Okay, sorry for all interrupts. So I just repeated again. So yeah, so I'm going to mute everyone. So I don't want interrupts from now onwards. So I mute everyone. Please cooperate. Yeah, so I just muted everyone to like I just don't want to interrupt from now onwards. So yeah, if anyone have anything, so just please let me know through the chats. I hope this like we are all are in a mute, so I think so. Yeah. So okay. So now we start our session. So this is basically I'm just showing you I'm just showing you how I solve the problem and all. So before that, I just want to give you the complete assurance like how I really solve whatever I learn. So basically, this is a bidirectional LSTM. Just see the network only. So in this here you can see there is a sequence. There is a models, and this is my model. So inside my model, here there is a bidirectional LSTM, and see this is a bidirection and this is a LSTM. I'm not going to tell you, not going to describe, not going to give you details about this as of now. Just I'm showing you, I'm giving you assurance whatever we are learning in the concepts that things only we are going to do in a hands-on. Okay, so I'm just giving you that assurance means that things. So I just requested every participant, please be please be more active. Then only you can understand the concept. So I'm just we will revisit this thing after learning our theoretical knowledge and everything. So once we done our understanding and theoretical knowledge, then we are come again to the hands-on session. At that time, you can everything every participant can understanding every single point. So that is my that is my approach. So I'm just I'm just repeating the things because of due to the some small disturbances and all. So today I just make everyone please make a note. So today we are completely discuss about the and completely schedule this 3 hours into the 3 parts. So first part is understanding the problem, and second part is how to solve the problem. So what till we you people are learn. So what today I'm going to start and how the things are help me to solve the problem. So that is the point. And so second point is what is the things like what is LSTMs and what is bidirectional LSTM, what is the GRUs, and what is autoencoder. So all are a neural network, a kind of neural network. So what the things are and how. So what is the intuition behind that things and all. So I'm going to start and I'm going to give a complete understanding about it. After completing those two things, then we are come again and see hands on how we solve the problem using our learning. So that is the approach. So I'm just repeated this to understanding detail. So just so as per our plan. So I'm just started with the problem statement. So you can see like learning a technical, learning a neural network is very like it is useful whenever you apply the whatever you learn as a neural network or whatever the concept you learn, that should be applied, that should be work at one problem. So you need to apply that concept to solving one problem. So that is the main thing in a neural network. So that is the thing we need to discuss. Okay. So and one more thing, the very important to every practitioner is, so first you need to understanding what is the problem and what kind of problem it is. So that requires some experience and all. So as of now, as a beginner or as a fresher in this area, don't think very deeply. Just consider whatever the competition or whatever the things are considered. Just make a note of it and go through this for as of now as a beginner. So I just recommended there is in data science or in artificial intelligence. This is a flow. The flow is first to figure out the problem, and inside a problem, then classify the problem. Means whether it is supervised learning or unsupervised learning or reinforcement learning or what kind of problem it is. Whether it is a classification problem or regression problem, what kind of problem it is. We need to categorize the problem statement first. So, and after categorizing the problem statement, we need to consider the loss function. What kind of loss we need to consider? Like if it is in classification problem, then we need to consider only whether it is a category, how much it is classified, means, what is the accuracy is our metrics to evaluate the performance. So what is a loss is a categorical cross entropy loss is a loss to determine the for with respect to our problem, then we will determine the loss. If it is in a regression problem, then we determine the loss as a MSC. And one more thing, if anyone have any doubts, please send your doubts or questions through chat. So then that will be useful for me to come back and down. Like if anyone is not, most of the people are not understanding, then I will I repeated those topic again. Okay. Is my screen is visible to everyone? I'm not sharing any slides. I'm just sharing a Google problem. So yeah, please anyone respond that. I'm sharing only Google problems, not the screens. Okay. Yeah, I'm not share. I'm till now I didn't share any slides. Okay. Okay. So yeah. Okay. So this is a structure. So yeah. Okay, so now what I'm trying to do, so first frame the problem. So don't go directly into the neural network or whatever the techniques you are using. Don't go directly into that things. First you need to understanding what is the problem and what kind of problem it is, what is the loss function and everything. So that is very important. So here in this Google Brains project, I'm going to give the explanation for this. So Google Brains, this project is all about a ventilator prediction, pressure prediction. So ventilator pressure prediction is so we need to predict every timestamp. At every timestamp, we need to predict the pressure which is required for the patient. So we need to predict the pressure which is required for the patient at every timestamp. So for that reason, this problem is a time series problem. Like the continuous learning should be there, and there is a dependency of past experience, past information. Like based on the past information, then the future prediction should be comes, right? So that is one of the first note. So that is the first note. So basically, so because of that reason, so we are considering this problem as a like a sequence learning problem. So this problem is after understanding, after going with the problem statement, I can clearly understand that this problem is categorized as a sequence learning problem. So now what I am going to do, what is the evaluation, how to evaluate my model, and what is the loss I'm going to treat. Okay, so here in this competition, they make a loss is mean absolute error. So I hope everyone is know about a mean absolute error. Error means just leave the word error. You know the mean absolute value. So this basically mean absolute error. So mean absolute error is nothing but first you have a after doing everything you predict some value. So then what we are going to do based on our predicted value, and we have also our true value. Okay, so what we are trying to do is we need to compute the error, how much of error is going to occur with comparing with our true value with prediction value. Okay, so that is the thing. Okay, so that is the thing basically required. So this is all about the error. So now, so I hope everyone is, this is a sequence problem, and the error, the matrix is error. So now I'm going to share my slides. So yeah, so what today we are going to learn? So today we are going to learn about LSTMs and bidirectional LSTMs, GRUs, autoencoders. Yeah, so now I'm sharing my screen. So I hope everyone is visible, like able to view my screen. So these are the slides. So I'm just started the slides. Yeah, so yeah, okay. So now yeah, now we already saw about the problem and what kind of problem it is. We already considered it. And so now we are going to think about the solution. For the solution, I am just giving you. I'm going to use bidirectional LSTM for my problem. So if see without understanding what bidirectional LSTM, if I directly use a bidirectional LSTM in my coding, that is very useless. So that's reason I am going to show you what is the LSTM, what is the bidirectional LSTM, what is GRU, what is the autoencoders and every point. So okay, yeah. Okay, let's start our slides and let's start our conceptual theoretical understanding. Okay, so first I'm going to, yeah. So first I'm just taking again, I'm going to consider the problems with RNNs. So basically this is a very basic point we need to consider every time whenever we are going for LSTMs. So basically LSTMs comes after RNNs. So first we need to see the problems with RNNs. So the problem is when we dealing with time series, basically our problem is time series problem. I already told you. So when we dealing with time series, it tends to forget the old information. When there is no distinct relation between unknown, means there is no, like if the length of, means the length of our input is very long, then the information, the old information is completely forgot. The model is not able to remember the old information because of unknown length and because of completely very huge length or huge unknown length. So due to that reason, our model is not able to remember the old information. Okay, because this RNNs are like a memory, so that memory having a limited size and everything. So inside a limited size and everything, so we are not able to remember the old information because of limited size and because of the flow. Okay, that is a problem with RNN. Okay, first problem, especially in time series. Okay, now the another problem is a vanishing gradient. I hope everyone is clear about vanishing gradient. Vanishing gradient problem is nothing but if in a neural network after means whenever when in a neural network while during a training, if the weights are not updated, then the problem is called as vanishing gradient. Weights are not updated means then our training is went into the local minima. So that is a reason for vanishing gradient. So that is a problem. Okay. Is my voice is clear? Is my voice is clear? So someone just pinged me no voice. So that's the reason I'm just again checking. Yeah, but someone saying yes, right? So what is okay? Yeah, it is clear. So not much clear. Okay, so it is clear. So if anyone facing any issues, please check yourself. Is there any problem? Okay. Yeah. Okay, so I already told you like a vanishing gradient. I think vanishing gradient problem. You can understand. You already understand the vanishing gradient problem. So vanishing gradient problem. There are two major problems with RNNs. Okay. Now I'm going to start with the LSTMs. So in LSTMs, basically in complete block of LSTM, there is a icons and there is a symbols. So maybe there is okay. Yeah. Okay. Okay, please, I request everyone, don't put like normal questions, any technical questions. I just encourage everyone to enter only technical questions because it disturbs the flow. Okay, yeah. So now before going to start a LSTM block, so I'm going to give you, so in a LSTM block, these are the icons, and these are the things we are going to see. So now before going to that, I'm going to give you explanation about each and everything. So basically this block represents a neural network layer, and this block represents a point operation, a pointwise operator, and this arrow represents a vector transfer, and this arrow represents a concatenation operation, and this arrow represents a copy operation, and this represents a sigmoid layer output, the number between 0 and 1. So it determines how much of components we should go through, and this is the flow, like sigmoid activation flow. Okay, these are the icons mainly used in our complete block. So now I'm going to start LSTM. So this is the LSTM block. So here you can see, so this is the LSTM block, and this here basically, if you so basically our problem is the time series problem, right? So time series is represented with the T. So T means here xt means x the input at present position, and xt minus 1 means input at past position. Xt plus 1 is the input at future position. Okay, and at present position, this is the block. This is the one standard block of LSTM. So this is a one standard block of LSTM. I just repeat it again. So now I'm going to I'm going to give you detail about each and every terms and what is the block represents. Okay. So basically this is a standard block of LSTM, and these are the connections standard connection of LSTM. So this is the present time, and this is the present input, and this is their past input and past LSTM block, and this is the future input and their future block, and each block represents same. So every block is similar. So I'm going to reveal, and I'm going to give a complete understanding about a block, standard block. Okay. So now from LSTM, basically we have the outputs from the outputs from each block is current state and hidden information. So these are the every time we receive these two information as an output from the block, each block. Okay, so from each okay, so whenever our block will train and our block will learn, after learning this, then what will be the output they are going to push is this is the current state and hidden representation. Here we are at xt input at t time, right? So it is input at t time, which means we required a previous output of our previous block. So the previous output of previous block is C, current state information of previous block, and hidden layer information of previous block. These are the two inputs given to our present block. Okay. Now, So basically it is like this. For first information, for first current input, it is like this. T minus 1. Here it is like this. This is the flow. And this is the equations. And I request every participant, please please see the equations. Equations are very useful. So through the equations only the block will be constructed. Okay. So here the final CT means the CT which is come from here. Those CT is calculated by using this formula. So as of now, just see like this. The formula is like this. FT. What is FT? You don't know, but only you know CT minus 1 and okay, CT minus 1 only. So this is basically this is the formula. So by the end of the means okay. So I just finish it. So basically this is the flow for CT. Now the core idea is this cell having so basically the core idea of LSTM is we are maintaining the current state information as well as hidden layer information. So for current state information we need a previous state information. Okay, so the previous state information. So here the core idea in cell is we need to get the previous state information, and based on our previous state information our current state information will be updated. That also taken as an input for our current state information. Okay. Okay. So before that basically we have a 3 gates. Actually just okay, just a wait second. So before starting this I just wanted to I just allow the participants. If actually I need to say I need to give one more information. Yeah. So just so till so I just give you why so what is RNNs. So actually so before going to start with the forgot gate and all gates, so I'm going to give you some example, some scenario example. Through that example, then everyone can understand the complete LSTM block. So without the example, it will become a bit difficult. So I just first I'm going to try to give you the complete the scenario and the understanding of LSTM block. Then I will start with like original LSTM block. Okay. So basically, so yeah. So for that reason, so I'm just giving you one scenario. Take an example. This is an example I'm going to construct. Okay. So basically, in an example, just like this. Basically, I'm a like if I'm a teacher, so I have a one fixed whiteboard. I have a fixed whiteboard. So just see the scenario. I have a fixed whiteboard and I need to take a class for 2 hours. For example, I have a fixed whiteboard and I need to take a class for 2 hours, and I need to use I must use only that fixed whiteboard only. I don't have other whiteboards or other resources to use to explain the class for next 2 hours. So I need to use only this fixed sized whiteboard. Okay. So how I started? I started here and to explain. I just started at my first half an hour or first 10 minutes. I started here and I started explaining here something I wrote here. I wrote here. So so I just started here. So after an half an hour, I come here. So actually my session is 2 hours, right? So for example, I have a session of 2 hours. So then I started here and again I go after. So here at this point I'm at after 1.5 hour after an hour. So after an half an hour, I am at this point. So at this point, I just wrote like this. After 1 hour, I am writing like this. Again, I will go here, and again I go here. I will go here. Then after 1.5 hour, after 1.5 hour, my board is completely filled. I don't have a space to fill the information. So again, what I try to do, my only thing is I need to put every information in this board. So I need to put here so here some space is there. So I try to after 1.5 hour. Actually, till I have remaining 1.5 half an hour. So in that half an hour, again I need to give the lecture. So for that lecture, I'm writing the information which is in free spaces. So here some free space is there. For example, here is space is there, here the free space is there, somewhere here the free space is there, somewhere here the space is there. So I ask a question to like after 2 hours my board is like this. Okay, my board is like this, and the students are not able to traverse to the starting and final. So yeah, I allow the any of one audience is till now is it is clear.
Yes, sir.
Yeah, just if you are a teacher, you trying to give a lecture in a whiteboard, the board is fixed size, you need to give complete your lecture using that board only. So after 1.5 hours your board is completely filled, but you have very small spaces. For remaining half an hour you need to use that spaces to fill your information. So for that reason, I just want to fill my information, I don't want to make a flow. So for that reason, I just filled with remaining spaces. Whenever any spaces available, I just use the spaces and all. So now my question is, so will a student is able to understand in complete flow using this information? Yeah, just my question is, so anyone can answer. Will the student is understanding complete information from starting to end with using using this board presentation? So basically it is no. So it is not easy to understanding the flow. So that is the problem with Warangal. So here I am mapping the terms here. Okay. So the first term is here, this blackboard is called as a memory. Okay. The memory which is placed in a RNN cell. This information is called as information is called as input. So actually, so I'm muting every audience, so it is making some noise. So that is my basically that is my intuition. So okay, so yeah, here so basically here our fixed board is a memory cell which is placed in a RNN, and this information is our input. And basically, for example, if you see the inputs to the RNNs, for example, in case of movie review analysis, or in case of, let us take an example of movie review analysis. Movie review means the user or the customer, like the user or the customer provided the review of the movie. That that review containing some 4 to 1 big paragraph, like a very big paragraph containing 10 sentences. Okay, so the 10 sentences is a input to our blog. Okay, so what RNN is trying to do is just RNN is trying to put the all the 10 sentences in this their blog. So due to that reason, it doesn't have a proper flow of information and the proper preferences of words and all. So that is a problem because of more information, and because of time series, very huge time series reason. So it is not able to completely have a flow of information because of fixed size. And here what RNN is trying to do is, RNN is trying to read every information. It's trying to read every information, and it's trying to allocate, and it's trying to store every information. So that is the first. So basically, the first problem is a fixed size board. Okay, and second problem is because of long length input, longer time series input. And third problem is RNN is try to remember everything. Try to remember everything. So that is basically RNN flow. Okay. So now I hope everyone is clear with RNN flow. Now what I am trying to do. Now I just, so I hope everyone is clear with RNN flow and this information, whatever we discussed. Okay. So now I am going to introduce the LSTMs. Okay. Yeah. So how LSTMs comes and how the LSTMs solving our problem. So now again I am taking same whiteboard with same fixed whatever the memory is there. So same fixed memory is there. But what I am trying to do here now is I'm going to introduce the three operations. Three operation I'm going to introduce. First operation is selective read. Okay, selective read. And second operation is selective write. Okay, and third operation is selective forgot. Okay, so just take a note of these three operations. I'm going to give you explanation for these three operations. First operation is selective read. Selective, just concerned that word selective. Selective means we are only concentrating high valuable information only. High valuable information only we are considering. Okay. And selective write, same. Out of reading whatever we read, that high valuable information, that information is going to write here. And after these two operation, we are going to use the operation called the selective forgot. Forgot means, see, for example, let us take an example here. Before forgot, I'm going to give you one example. There are two operations are there. First operation is a plus b, and second operation is a plus b plus c. So you are trying to do these two operations, and you have a value, b value, c value. But your final target is to find this operation. So what my question is, so is it required to hold a plus b? Is it required? Because it is already present in this information. This a plus b information is already there here in this equation. So if this equation if this equation is present, then there is no importance of this equation a plus b. So for that reason, what I am going to do, I am going to forgot this information. Okay, I'm going to forget this information because it is already, this information is already present in this information. Due to that reason, this information is loaded. So due to that reason, this information is not required. Okay. So this operation is performed by the selective forgot. So out of all information, which information is already present in another information, so that kind of information is we are going to forgot. Forgot means we are going to remove that information. Okay. These are the three fundamental and standard operation we are going to do in our complete LSTM. Okay, LSTM is flow like this. So what I'm going to do. So I already told you that our input is 10 sentences, for example. So what I'm trying to do, I just started writing one up to here. I just started writing. I just started writing here. So here I'm at fourth sentence. For example, I'm at a fourth sentence. Now my target is so now I am going to look back to my complete sentence, and I am trying to do the operations here. So now for the first operation is selective read. Selective read means first operation, basically in this scenario, first operation comes as this operation. So whenever I start a fifth sentence, first thing I need to see these things. First one is selective forgot. So out of all information, which information is not giving high weightages, which information is not giving high weightages, those information I am going to forgot. Those information I am going to forgot. Okay. So how I forgot, I will tell you in this next slide. Okay. So first operation is I am going to forgot whatever the information is present there. So I am going to do the forgot information, and now I am going to start a selective read. So after forgetting, we have some information. So out of that information, so I'm reading only important information only. In movie review, in a complete review, we have some words only or some sentences only. That sentences are giving very more weightages to the overview of that review. For example, this movie is awesome, or this movie is not good, this movie is very bored, or something like this. So those sentences are giving more weightage. So we need to figure out those sentences, and we need to try to read those sentences only. Okay, that operation is called as a selective write operation. After reading those information, I am doing selective write. So after reading that thing, again I will start my writing here from here. Okay, I will start like this. Again I will go back here, and out of this, for example, at seventh sentence, again I will start. Again I will look back, and again I will look at my forgot operation. Is there any information need to forgot? And after forgetting, again I will think about what is the information need to read, and after that what is the information I need to write in this board. So finally, what our board is like this. Only finally, what our board is going to be like this. So so we have a complete board. So what our board is, so what going to happen is, so in our complete board, only we are writing the information which is having more weightages and complete sentences. So basically this is the advantages with the RNNs. This is the flow in a RNNs. Okay, sorry. This is the disadvantage with RNNs and advantage with LSTMs. So this is the complete flow in this LSTMs. So now I hope everyone is clear. So I just unmute audience. If anyone have a doubt, just ask me doubt. I'm just so if it is repeated, I'm not allow only unique doubts only. Okay. So otherwise, I'm giving 2 minutes. So if anyone having any doubts, I'm going to give you how I'm going to interlink these three operations into exactly in all LSTMs. Okay. Yeah. I think everyone is clear. So I'm moving forward. Okay. So I hope everyone is clear with this understanding. Then our slides, then our exact information will come here. Okay. So here, just I'm going to go through slides and you can get the point. So basically, I already told you there are three operations. So this is with respect to forgot gate operation, and this is with respect to input gate operation. This is with respect to output gate operation. So just map input is read and output is a write. Okay. Okay, this is our existing information, and here you can see this is our forgot gate and this is our input gate. Okay, this is our first forgot gate. So here you can see this is our previous information. This previous information come like this. Just please observe these points. So the previous information is come like this, and our present information is also come like this. After activation function, our information is come here, and this is our gate. So inside at this gate we have our previous information and our present information. So here our forgot gate operation perform. So this is the forgot gate. So after forgot gate, then that after forgot gate, that information is given to the input gate. So this is our input gate. Okay. So here what happens to the input gate? Again here input gate is our present input is come like this. After activation function, it is going here. After here, it is going here. So here again we took the information from forgot gate as well as the present information. Again we do the input gate operation. After our input gate operation, again we are send our output our information to the output gate. So here this output gate is like this. Again same, this present input is given through the activation. After activation, that information is here. For this output gate, we have two things. First thing is our input gate output and our present input. Okay. So these are the three gates. Okay. The sigmoid gate, how much information is flow. So sigmoid is indicates this control what is how much of information we need to flow. Means I already told you it controls the importance of information. It controls the importance of sentences or words. Okay. Okay. So now what? So then input gate decides which this decide what information is needed to add to the cell. So basically this is selective read. Okay. Similar with selective read operation. Now this is our write operation which is going to write to the next cell. So output gate controls what goes into the output. So it is going to write output. So what information is going to write as output, it is going to control. Okay. So basically these are the three operations which perform in a standard LSTM cell. Okay. So now I'm going to give you the complete flow. So you can ask me why tanh instead. So here the tanh is there. So why the tanh is you are using instead of sigmoid. So you already told you like I hope everyone is know about sigmoid and there is a problem of vanishing gradient. So due to the reason I am using tanh. Okay. So now I am going to show you the complete flow step by step. Okay. So from here, so here see this block only. So now I'm now so please everyone be alert. So I'm going to showing you a complete individual block and individual block flow step by step. Okay. Okay, so here you can see this is the flow. So first we have a two values. First value is our present input, and second value is previous output, previous layer output, hidden layer information, that is the h t minus 1, and this is our present input. Those true values are given to our forgot gate. After those two values, we are using activation function. After activation function, this is our forgot gate information. Okay, so for this, from this information, what I am trying to do, I am trying to pick the current state information. That current state information and forgot gate information, I am going to do the gating operation. So basically, this is the equation for which we perform during forgot gate. So here, this is the sigmoid, this is the activation function, and this is the weights, and this is the hidden first in this hidden previous hidden layer input, and this is our present input, and this is the bias input. So this is the formula for doing a forgot gate. Okay. So now what I'm doing, so after forgot gate, I'm going to the input gate. Input gate means selective read operation. Okay. So in this selective read operation, this input IT decide what components need to be updated, which means it will read only selective information. So using this formula, okay. So here the flow is like this. So this is our two inputs, and this is the selective gate activation function. And based on the activation function and based on our previous state information, we are going to decide what is the input we are going to forward to the output gate. So using temporary current state information. This is the temporary current state information. Okay. Temporary current state information. This is the final current cell state information. Okay, the final that final cell state information is updated by using this formula. Here FT, you know, CT minus, it is taken from here. IT, you know, CT dash is means temporary current state information is this. So this information is there. Finally, by using this operation, this multiplication and addition operation, we are going to compute the CT. This CT is the output from a block. This is the one output, current cell update output, and this is the hidden layer information output. So how our hidden layer information is output, we will see. So this is called as a selective write operation. In terms of our scenario, this is like a selective write. It decide what part of cell state is going to be a output. So going to be a write operation. So here, this is the formula, which is similar with all the formulas. And this is the activation. This is the ST is the final operation. So by using this tan-h operation. So tan-h is a final activation function we are going to do on a CET along with the output gate. Okay, this is our final hidden layer information. So basically, this is the basic standard structure and flow of information in a LSTM block. Okay, so I hope everyone is clear. Just I am giving you 2 seconds. Sorry, 2 minutes. If anyone have doubts, so please let me. So I will move to the bidirectional LSTM. Yeah, I think everyone is clear. Yeah, please let me know. This is very important. So if anyone have any doubts still, I will 100%.
Sir, will you explain the second block?
This one?
Sir.
This one, right? Yeah. Yeah. Okay. So here, so what happens here is, so basically we require two things. So basically, hidden means LSTMs is going to provide you two outputs. First output is a cell state, that is CT, and another one is a hidden layer information. Hidden layer information. Okay, those are the two outputs we are going to produce for each standard cell. Okay, that is the point one. So here, what further things? What we have 3 gates. You know, first gate is a forgot gate, and second gate is the input gate, and third gate is the output gate. So first, what happens from input gate? What is going to do from input gate? After input gate, you can get a information which is very important. Okay, so which is important to the. So what happened here is, so after doing this operation, so then the, so again what is what input gate is going to take is, first it take a present input as well as the previous hidden layer input, and these two input is taken and concatenated, and this is sent to the activation function of, this is basically, this is the input gate. Actually this is the input gate here. This is the input gate. These two are indicates the input gate. So what is going to do, it take the these two values and do the activation function and perform the and here simultaneously we need to have a temporary current cell information. Further thing, again we are doing the tan h on the same inputs. We are doing a tan h. Basically this is the another term, so don't confuse. This is the another term. Basically we have FT, IT and OT are the three gates, and we have a temporary state and current state, temporary current state and current state. So don't confuse. So here this is one flow and this is the another flow, and again these two flows are concatenated here and sent to this final hidden final input gate. So here what happens, here it took from here this information and this information, it will do the operation called multiplication. I mean, so it do the operation as per the formula, and then it will provide the output. Okay. Just
Yes, sir.
yeah, see, just it is a flow. Just like, see, I'm going to just move the cursor. Just to see, this is a basically flow. Okay. So this is one flow for with respect to input information. This is with respect to the temporary current state information. Finally, this will do the addition operation. After addition operation, it is sent to the input gate, final input gate. That will decide what is the, that will decide the selective read operation. Okay. Okay. So then in the next slide, I am going to show you one more thing. In that thing, I am going to
fourth one, sir. Fourth one, last one, sir. Once again, please.
Okay.
Last one, fourth one.
Yeah, fourth one is like, see, what is the fourth one is, here you can see the same information. Just to remember 2 points. The first point is this, whatever the information of this xt minus 1 and xt minus is common to every gate. That is a point 1. So that is common to every gate and given to every gate. But what is the second point is, there is a flow. Here you can see there is a flow. That flow here, that flow will decide the final information. Okay. Here what is going to, so that is the second point. So now with respect to the output gate, so here these are the two these are the two information, these are the two inputs which is given to the output block. This is final, this is the final output gate. Okay, so this is the final output gate. So what that output gate is required here is, first thing is it requires the output block information as well as it requires the selective selective read information. So by using those two information, then it will update the final output information as a hidden layer information. So finally, this is the hidden layer information. Okay. It
Sir,
took
sir, here tan hyperbolic, sir, here tan hyperbolic function has been used 2 times. What is the reason behind it?
What is the what is the function?
Tan hyperbolic, sir. Tan hyperbolic has been used 2 times.
Tan. Basically, we have a two outputs now. I already told you for basic standard block of LSTM having two outputs. First output is a current state, and second output is a hidden layer information, hidden layer information. So for current state information, we need to do finally we need to do the activation function. So for that reason, this tan h is the activation function which is performed on the current state output. And here this is the hidden layer information output. So this is the temporary current state output, and this is the final current state output. Okay. So basically we need a two outputs. Further thing, we require a two tan h activation function for output.
Sir, which one is current and which one, sir? Once again, sir, I'm not getting it.
So basically this is the temporary current input. This is the final current input. Okay. Yeah, just I'm giving also already. Okay, so I will. So here you can see here what happens. Here just you can see this is our IT, right? So this is the IT. So first I'm going to do the TANH here to get the current temporary current state information. Okay, so this is the temporary current state information, and that information is again so that information is given here. So here this operation, whatever we did, this operation again this is given as an input to the final. This is the final current state. So this is comes here. So this is the final current state. This state requires two things. First one is a previous current state information, temporary current state information, forgot gate and input gate. So finally, by using this formula, we provided output as a current state information. Okay. Yeah, so I'm going to show you one more slide. In the slide, you can bit clear. So that is some visualization flow. That slide is I'm using some visualization flow, so that will give you more clarity. So this is again those two are the basic blocks. Okay. So those two are the basic blocks. This is block with respect to RNNs. This block is with respect to LSTMs. So here you can see we have only one input and one hidden layer output. So that reason we are only using one activation function. But here we require two outputs. So for that reason we required two outputs we are going to push. First one is the cell state and another one is the hidden layer information state. So for that we have two activation functions. So now I'm going to, so these are the set of equations we are used in this complete structure. So with respect to gates, these are the equations. So this is so basically it's like this. In a high level of view, RNN is like this. So in RNNs only this is the present input and hidden layer input, previous hidden layer input, and we will push the outputs as well as the hidden layer output for the next layer. But in LSTM, here you can see this is the hidden layer. This is the input of time t, and we have two outputs. First one is the current state and hidden layer information. Okay. So from this we are going to get a current state information. So yeah, the question is. To overcome management variant problem, we need to have a certain perspective, which certainly now goes to 0. TANH is a good function. Yeah, that is exactly the use of that things. Okay. Okay, so then this is a CT, and so finally we are these are the two. So this is the basic block of LSTM. Okay, this is the basic block. This is the flow. So it is. So I hope everyone is clear. So now I'm going to show you the complete flow from this visualization. Just go through the visualization only. Okay, so here first basically this is the operation. So yeah, so Z indicates operations. So that tree operation, it indicates any operation. So I will tell you. So basically, yeah, here you can see this is first gate. This is with respect to the first gate. Basically, this is the operation. Basically, this is the standard operation. But with respect to our gates, these are the equations. Okay. So these are the information. So I'm just giving you the flow just to understand. I'm just go through the step-by-step flow. Okay. Now on top of it, what is going to happen? Just what is going to happen? Just to see. See this. So don't worry. This is a kind of visualization which gives the equation and flow. So I'm going to share the slides. So using this slide, you can understand in detail. So here you can see this is the flow basically from. So it is just like a detailed visualization of this block. So yeah, so for time purpose, I'm not going to give you more information about this because we need to consider we need to go with the remaining topics also. But it's a kind of opening like for a complete visualization purpose. I'm just to create this. I'm just using these slides to get a complete visualization. So I'm going to share this slides. Just use just you do like this, then you can get a complete visualization. Okay, now I hope now I hope everyone is clear with this visualization. So now what I'm trying to do, I just want to recapture everything. So this is a complete so now here you can see the exact what read and write operation is going on. Okay, so shit. Okay. So just like okay, I'm using this blue pen, just see on blue pen. Okay. So basically we so this is the one block of information. Just see this is a block of disturbing here. Okay, so I'm just using the pointer only. Okay, so here is our so just this is a set of block. So now I'm going to give you explanation with respect to how real time and how exactly is what going to happen. So basically this indicates our input. Just to see this, this is our input, and here this is our previous block. This is our previous output block. So see this is our previous output block. So now our set of read start from here. Okay. So what happened here is, so first this is a block, and this for you can see here this is the W, and this is UT, and this is our XT, and this now we are doing this operation, first operation. Okay. And now after that for XT we need to do this operation, and after that operation we need to do the selective read and selective forgot. After doing this two selective read and forgot, then we are going to put that output by using selective write. So finally this is our ST, means our hidden layer information output. So these are the set of equations. So with respect to gates, these are the equations, and with respect to states, I already told you this is a temporary state which is taken here. Okay, so this is a final state. So this is CT, and I just take a nomenclature here as a state instead of C. I'm just placing as a S. So this indicates temporary state, temporary current state, and after this equation finally gives the final current state, and this equation gives the hidden layer and final hidden layer information. So basically these are the gates, and these are the set of these are the states, and these are the set of equations, and this is the what exactly going to happen. This is the flow. Okay, this IT is a weightages box. So here you can see this is basically we have a 1. So what this 0.8 indicates, this 0.8 indicates with respect to this operation, this 0.4 information is very huge, very important. So that importance is we are going to place here. So these blocks and these values use the importance of the information with respect to like with respect to this hidden layer, or with respect to our inputs. So here 0.9 means very important, 0.7 is important. This is also very important. So this based on these values we can control. If it is 0, then the information which is present, it will become 0. That indicates it is completely not important. So basically this is what is going to happen in terms of numbers. I mean what going to exactly happen while during training. So this is the blocks actually. So yeah, I hope everyone is clear. So I'm just moving to next slide. That is bidirectional LSTM. So before bidirectional LSTM, I'm just okay. These are the so now I'm going to give you understanding about the bidirectional LSTM. Now I hope everyone is clear. Still, if anyone has doubts, please let me know. I will try to figure out. Yeah, thank you. So yeah, so now okay, so I hope everyone is clear with LSTM, standard LSTM, and their blocks and their flow. And just see, my only suggestion to everyone, just understand the block and their intuitions. There is no requirement in coding or in a hands-on session. There is no requirement of writing codes and remembering all the things. Just you need to understand the flow, what is which operation is doing what. That is only required to understand. The formulas, you just remember the formulas. That is not at all very important to have a like there is no exam, so there is no requirement. So basically we are using TensorFlow, right? In TensorFlow everything will be take care with TensorFlow, that equations whatever we are shown in the equations, so that equations will take care by the TensorFlow. For a developer or for a researcher, there is no requirement of remembering things. Okay. So now till now we are understanding the concepts with regarding LSTM. So now I introduce a bidirectional LSTM. So basically this bidirectional LSTM is very simple. It is like so here you can see yeah, the only thing here is why this bidirectional LSTM coming to the picture. I'm going to tell you. So for example, so basically in a see, the only thing see, for example, I'm going to give a movie review. Again, I'm taking same example, movie review. Basically some sentences are there, so some sentences are there, some sentences are there. So what happens? So for example, I just write it with negative statements. First I write it with a negative statement like the movie is not good, the hero is not acting well, something. After some point of time, what I'm going to do, I'm going to give with a positive opinion. Like still it is good movie, the screenplay is good, the direction is good, something like this. So after some time I'm going to give some words which is implicates a positive information. So I'm going to give the positive words after some negative words. So what is going to happen? So now overall, so what happened here is, so whenever you are at this point, you have a so for example, you are at this point, you have only the information about the previous point. You don't have about the future information, future points. So what happens? You updated or you do the operation based on our so what happens here? We are doing operations, we are doing weight updates or giving importance based on our previous information, not on our future information. This is the problem basically. So what happens? How this problem will be solved means. So now the bidirectional LSTM comes to the picture. So what is going to happen here is, so this bidirectional LSTM can learn based on future information as well as the past information. Okay, so we are at so for example, this is some line. So we are at this position. We have a past information and we have a future information. So in normal LSTM, in a simple LSTM, there is no scope of learning future information. Only we have a scope and we have only have a knowledge on past information only. We don't have a knowledge on future information. So what this bidirectional LSTM is doing? So using bidirectional LSTM, now we can get a future information also along with past information. So at that time, so for example, at this time, you can get both information, future and past. Based on those two information, you are going to give the importance of the sentences. So this is the basic flow in a bidirectional LSTM. So, but here only thing here is, so what is here is a single unit of LSTMs is used in a different fashion. So different fashion to combine and make it that fashion is called fashion into the bidirectional LSTM. That is a simple. So just here the difference between simple LSTM and bidirectional LSTM is, first thing is with respect to architecture. In that architecture, we are using two blocks of two simple LSTM layers in a different fashion or different flow. Okay, so that is the first difference. And second difference is in the simple LSTM, we have only information about previous information, but in bidirectional LSTM, we have both the previous and future information. So here, so that is two differences. Okay, now with respect to architecture, I'm going to tell you. Okay, here with respect to architecture, see what we are doing, we are placing one unit of LSTM in this direction, in a forward direction, as well as we are placing one unit of LSTM with respect to the backward direction. Okay, so then this complete thing is called as one unit. So finally, this complete unit is called as bidirectional layer. So with combining these two layers, and finally we call as bidirectional LSTM layer. Okay. Okay, so simple, yeah, simple. So the one is from forward back propagation, and one is towards the backward propagation. This is very simple. Okay, so this cell is similar. See, this LSTM cell is same. This LSTM is same as a standard and simple LSTM. But the thing is, the developing architecture and placing LSTM is different. Okay. Here, okay. Now what I will tell the information. So we connected two hidden hidden layers in a opposite direction to the same output. So here you can see. So here you can see this is our final output, but we have information about two directional LSTMs. By the backward propagation LSTM information we have, forward propagation information we have. How I will tell you. So here you can see I'm just changing the marker. Here this is our input, and this is our forward this is our backward LSTM layer. So what happens, first it will go here and it will do the operation. So this LSTM is going to pump in a two way. First is in this direction for backward propagation, and with respect to this input, like this, with respect to T1 input, we need to have a T1 output, na? So for that, so it is pumping output from here. So here this information is again taken as a output. Again. So here what happens here? So here in forward processing, so what happens again? We have a LSTM. So the LSTM is flowing like this. Finally, this LSTM with respect to T1 is like this here. So this LSTM requires our input, na? So here I'm going to change color code. So what happens here? This. Okay, so here for this LSTM layer, the output should be same. So for that reason, I'm taking the output from here. So now what I'm doing, I'm again taking an input. The output and input are same, but the way of taking and the way of architecture is different. So this is for backward propagation, you already saw. Then our forward propagation, again we take the same input from here to here, and we do the backward propagation, forward propagation. Then we are like from this layer, we have a final output information. So from here we have a output. Similarly, for backward propagation, we have one more output. So from here we go here, and from here we have here. So finally, we at the same time we have two blocks information. So that is a statement. So that is a statement basically here. Two hidden layers in a different direction to the same output. So the output layer can get the information in past through the backward propagation, as well as in future to the forward propagation state. Simultaneously, make that point as a note. Okay, so through this learning representation from feature timestamps, then we can get a good understanding. So that is good understanding, we can eliminate the ambiguity. So that is the main concern and main advantage with respect to the bidirectional LSTM. So I hope everyone is clear. Yeah, I hope everyone is clear. So if anyone have a doubt, I'm just giving 2 minutes, so then we can ask me. Okay, so this is a basic flow. So till now we understand the LSTM and bidirectional LSTM. Till anyone have any doubt, please let me know. So don't have a doubts with yourself. Like, please let me know.
Yes, sir. Yes, sir.
And just,
Sir, we'll
yeah,
get
and just
two
repeated
outputs. No,
everyone.
which one you have to consider? Like forward.
Yeah,
Hello.
here these two outputs are taken here. This is not a two
Our
outputs.
two
These are
outputs
the
are same. I mean, like we are getting two inlets to that
no.
output. No, sir.
No. I will just wait a second.
Okay.
So here, so in
Forward LSTM and backward LSTM. So we are connecting
yeah,
two
okay,
to the output.
yeah.
So I am thinking that we'll get two output.
Mm-hmm.
No,
Okay.
I understood like we are getting two
We are
outputs.
in a hardware, exactly in a network or in a coding. This inside
Okay.
architecture itself, we are doing concatenation. Okay, from
Okay.
both information.
No, my doubt is we will
We
get
are
one output or
combining
we'll get
both,
two
no?
output.
No, we are combining both, no, sir. Forward
yes,
and
sir.
forward and the backward, which means
Mhm.
the past and the future thing we are concatenating, and then we get only single output, isn't it? Because we are combining.
Yeah. So
Okay,
so
we'll get
basically,
another output. Okay.
yeah. So what is going to try to this? Basically, what I am trying to say is, so basically in a information, in a complete information, for example, in a movie review, because movie review or set of information is there. So our target is to give the importance of, suppose the word is there, good or bad or something, some word is there. So finally, our target to get a complete overview, so complete sentences, we need to get a final review, whether it is negative review or positive review. This is our final target. This is our with respect to there are multiple ways are there. So this is our basically this is our final things. But
Yeah.
but what the point is, for every word or for every output, what is going to happen is, so we are doing some weight updates and giving importance to each word we are doing. So what? So these words or this information is indicates the final output information. So what happened here? So for each word, we are giving importance or we are giving the weights with respect to both forward processing as well as the backward processing. So that is the big advantage with bidirectional LSTM. So after considering forward processing and backward processing, we combine those information and give the weights to the each word or each output for each timestamp output. Finally, based on complete information, we are going to classify whether it is positive or negative. So that is the basic flow in bidirectional LSTM. And internally, that will take care by the TensorFlow. So there is no means we don't do anything. So I just already told you in my architecture I just use bidirectional. Then I'm using LSTM. So that syntax itself enough to for our beginners or some our researcher or developer. So using that syntax we can develop a bidirectional LSTM. So for our input, okay. So internally that will take care by TensorFlow. But conceptually, but theoretical understanding and concept wise, this is the basic flow and structure for bidirectional LSTM.
In each block of LSTM, like in backward, arrow is going from left to right, and in backward from right to left, LSTM to LSTM, LSTM to LSTM. What is the meaning of this? I'm not able to understand.
So basically, see, for example, the time series I already told you. Basically, the sequence learning, most of the people see. Basically, this is the flow. For example, so this is basically sequence to sequence chart model. So these models are the one of the applications of bidirectional LSTM or LSTMs. So here, what happens here? This is the timestamp 1, at timestamp 2, timestamp 3, and timestamp 4. So for each timestamp and for each information, we need to have a block. Okay, so this is the block 2, block at timestamp T1, block at timestamp T2, block at timestamp T3. So it is like this. It is like this. So each block is at respect to timestamps. So here you can see this is with respect to T1, with respect to T2.
So these models were useful for speech recognition or which type of application?
No. Can you repeat again the question? I'm not clearly understanding.
Such type of blog that is like you told, how are you, like, then there will be some answer. So such type of strategy will be used for speech recognition or which type of application?
Yeah, I will tell you. I will cover that time. Just as of now, understanding these things. So I will tell you. Okay. Next slide, I will give you applications and all. So at that time, everyone can understand it. But as of now, this is a basic flow. I hope everyone is clear. So I'm just moving. So yeah. So okay. So now I'm going to. So now I'm going to start show you the applications of LSTMs. So first, so yeah, this is not a correct slide. Wait. See, just so I'm just so here basically. Actually, that I'm just fully focused on. Okay, so here you can see for both are on the same page. So yeah, here you can see. I hope everyone is clear with my screen. So here these are the applications of LSTMs. Till now in organizations also they are using. These are the applications we are using here. So first one is a speech recognition, and the second one is a mission translations. Third one is a image captioning, and fourth one is a sentiment analysis. So sentiment till now we took always we are till now we always took this example. So movie review or product review or Amazon, like any, if you see any website or like Flipkart or Amazon, there is a product reviews systems are there. So those are called as sentiment analysis, product reviews, and so those are categorized in this area. So then music generation, video activity recognition. So I'm going to give you these two applications. Basically, I'm going to give you more detail about these two applications. But with respect to LSTM, these are the applications, and with respect to RNNs also I have. So this with respect to RNNs more similar. So both are in the same page. RNNs and LSTMs are almost similar. The only difference is these having RNNs having some problems because of that. So basically, LSTMs is a like a kind of RNN, is a variant of RNNs basically. So same problems. So model languaging and text generation, mission translation, speech recognition, generative image description, video tagging, text summarization, call center analysis, face detections, and other many applications. So basically, these are the very popular and well-known applications of LSTMs and RNNs. So now I am going to show you in detail description about two applications. Okay. First one is so this is basically the sequence to sequence learning. So what this learning is basically everyone knows this is the basically a chart box. So if you give this as an input, so based on this input, then this is the LSTM encoder input. So based on this LSTM encoder input, it will going to give the LSTM encoder output. Okay. So yeah, just to see as an application, don't think about what is happening, how it is flowing, how the technical background. So don't think about it. Just take a note of only these are the applications. Just if you want to get a more knowledge on it, just go with everything needs to more in detail explanation. But in our session, we are morely on sentiment analysis as well as time series learning. Okay, so we are not more on a sequence to sequence chart application. Basically, these are very this area is very huge. So many applications are there. So within 1.5 2 hours, within 3 hours, it is not easy to cover each and every applications and all. So due to that reason, I'm in these sessions we are more focused on time series problem and sequence sentiment analysis problem. So I'm going to show you those two problems and those two applications. Okay. Okay. So this is a basic syntax here. Basic example and basic flow. So now I'm going to show you this is a live captioning application. So what this live captioning application is nothing but see what this live captioning application is. So basically you have an image, and if you give an image as an input, then finally this based on that image, then our application will tell the summary of that image. That is called as the image caption generation. So here you can see a man is wearing a so I don't know whether he's wearing hat or not. Like hat in terms on shoulder, I think. Shoulder on shoulder. So sorry, they're wearing things, and they have a that music instrument. And here the human is sitting at a table with the larger pizzas. Okay, so this is the caption that is generated. So here okay, so here these are the basically these are the captions. So there is a these are the misinformation. Basically I just given a wrong slide. So this, see, first these are the correct slides, the correct predicted slides here. So a dog is standing on a wooden, like under the wooden, like on a wooden. So here a little girl is sitting on a bed with a teddy bear. So basically this is a kind of application. The application is a image caption generation. Okay, so this is basically happen like this. So here first we are using CNNs to get information of image and their image information. After getting image information, we are going to do the LSTMs. So finally we predict the words and their information. Okay, so that is a basic flow. Here you can see this is the one of the best example. See, this is our Indian movie, one of Kamal Hassan movie. So what we are trying to do, we take the movie video as an input, and what we are trying to do is from that input, what we are trying to do is from that input we are make a frames. From the frames we are going to give the finally from using those frames we are going to give the caption. So here the caption is a man and a human ride a motorcycle. So a man and human are talking on the road. So based on these are the two captions generated based on the video with respect to their frames. Okay, so this is a kind of application of image caption generation. Okay, so second caption is a human is there. This is the video, and a human is a human is frying a food, and someone is frying a fish in a pot. So here, so the captions are generated two ways. So first one is human is there and is trying to get a food, and second one is what is so based on this information, it saying that is frying fish in a pot. So those are the two informations we got through this video. Okay, so this is a kind of application. So you can means that there are some misdetections and all there, but basically these are the applications where bidirectional LSTMs are there. So we have already. I'm going to show you one more thing. Actually, I have some. Is my screen is visible? Like I'm just on website, means on Google Kaggle. So is it visible to everyone or still in slide? I'm if any time remains, I'm going to show you this example also. But for your understanding, I'm taking this example into consideration. Okay, so here the example. Sorry. This is not an example. This is exactly an application. Not a simple example. It's like it's more like an application. Yeah, this is emotion recognition using bidirectional LSTM. So basically in Twitter, so we are using a database and dataset from Twitter dataset. So basically, so so every day, every user or Twitter, every person is posting their tweets in a Twitter. So what our project is doing is, so based on the tweet they posted on the Twitter, we are going to classify, we are going to figure out, recognize the emotion inside the Twitter. So we are so our aim is to classify the 6 different emotions. First emotion is sadness. Second emotion is anger. Third emotion is love. Fourth emotion is surprise, fear, joy. So what we are trying to do is, this is a kind of sentiment analysis application. So out of each tweet, we are trying to figure out the emotion from each tweet. Okay. So finally, so basically this is like, say for example, here is a fun, like after developing a model and after developing everything. So I'm not going to run the code because it's taking some time and taking so much like some coding runtime. So for that, I'm not running the code. I'm just show you the example here. So finally, what I'm trying to do, finally I make everything. I do my model, I do production also. Finally, after production, if you give the sample input at a feature, this is at a feature. So this is like no one told me when I'm missing the starting gun. So it is like some quotes are like, she is flying high after success product launch. So what is the feeling? So so this tweet is her feeling. So now what we are trying to do is, so what we are trying to do is, we need to figure out the emotion, whether this is the joy or this is the happiness or what kind of emotion it is from the sentences, from the tweets or sentences. So this is a kind of application. Okay. So these are the different kinds of application in LSTMs. Okay. Now, yeah. So I just want you to take a note from everyone. So yeah. So if see, so if everyone, so I just mute everyone. Yeah, I just want a small note from everyone. So till now, everyone is understanding about LSTM and bidirectional LSTM. So I can consider that statement. Like you say, everything is clear. So then we will move to the hands-on session, or we will move to the next. So basically, see what my target is. Whatever I'm trying to tell, I'm trying to complete with full-fledged, like theoretical understanding as well as coding implementation, as well as the exact in a complete and real-time application. I want to put to that knowledge. So that is my target here. So yeah, if you are everyone is clear with understanding, then I will move to the hands-on. So I'm trying to do this two things. So first one is our first project, that is Google Brains project, and second project is our emotion recognition. So this project also very useful, and this is very interesting and very realistic project. We are taking this project is completely a real-time project. It takes a database from Twitter database, the Twitter publishing their database. Based on publish a Twitter database, we are going to construct the complete model. Okay. Okay. So yeah, if everyone is okay, then I'm going to move to the next step. Next, our third session.
What is this
Third part.
what is this function pandas or something?
Yeah,
Import.
pandas is yeah, sir. So I think in previous session they covered this pandas, NumPy, TensorFlow. I hope they covered.
NumPy we heard, but I don't know this pandas.
Okay, still okay, sir. I will tell, sir. Just give a minute. I mean, sir, if everyone is clear with the concept, understanding whatever we discuss in slides, then I'm going to start this coding session, and I'm going to give you explanation for each library and all. Okay. So I need everyone response. So if everyone is okay, then I'm going to start with these two projects. So then whatever you learn, and you will going to put in a hands-on and solving a problem. Okay.
Hey, I have one question.
Yeah, sir.
For that lady with pizza or that child with the bird, we see two pictures. Why one
Okay.
one with more clarity? Why there are two pictures?
Okay, where? These two pictures are. Okay. Yeah. Actually, this slide I just so I will tell you. Basically, what they're trying to prove is, in first slide they are going to give the correct scenarios. Means what is the scenario and how exactly our model is making. And second scenario, they are making they are showing the scenarios where our model is failing. So that is the thing. How it is failed also they will show. Okay, that is the that is the concept here. So here just see this slide. In this slide, basically what is trying to do. So what basically here. Okay, so this is the our input image. Okay, so our this application is the image caption generation application. So the final target of this application is based on the image you are going to put. So then based on the image, see, as a human beings we can see and we can recognize the things and we can know this is that a woman is throwing something in a park. So because our brain is already saw the different parks and our brain is saw the different kinds of that playing things, and our brain can remain saw so many scenarios like this. So because neural network is something our brain, so then as a human beings we can saw the things and we can after seeing the image and we can say this human is playing and showing something in a park and playing, so that human beings can say. But how a neural network, how the neural network, whether we are using two things. One is CNNs and another one is LSTMs. Whatever the things is there. But finally, what the neural network is learning, from where it is learning, that is the question. Okay. So for that question, so what the neural network is doing is I am going to. So first, this is our input. Okay. From this input, finally, from this input, our neural network is trying to figure out the important information area. So this is the important information area, more important information area. From this out of complete image. So this is the pixel and somewhere these are the complete image pixels or something is there. But these pixels are not giving more information. Only this pixel, this image, this portion of image is giving more information. So that things are by using CNNs and LSTMs, that things are we can identify. So that things we are going to, in second picture, out of complete information a complete image, which information is giving more weightage. So that is the second image representation. I hope that thing is understand now. So here you can see, so our statement is generated based on this white boarded or white screen statement. Okay. So here, this is in this image, this is the information. In this image, our target is dog only. So that's why it is white boarded here. In this information, our complete focus is on that board having stop. So here our focus is completely on. If you show to one person or any small kid, so if you show this image to the kid and ask them what do you see in this image, if you ask the question to the kid, what do you see in this image, then kid is saying that there is a signboard is there, the signboard containing stop as a letter, and that is a signboard which is placed there, and there is a mountains also, there is a background is a mountains also there. So that is the things their kids will saying. So similarly, so the kids are saying based on their brain and their information. So as a neural network, as a machine, can understanding through this through the important information. So for visualization purpose, they are again plotting the information which out of this information, out of this image, which image or which part of image is giving more weightage. So that is plotted here, which is highlighted in this white background. That's why these are the two images are taken here. Okay. So in this second scenario here, these are the misinformation cases. Here, basically these are some fruits or something, but still it is shown as a pizza. So this is a misinformation. And here you can see this is it look like more like a clock. So that's why a human holding a clock in her hands, because there is a hands here. These are the hands and these are the clocks. So our neural network is confused and our neural network focus on this and this. So finally saying wrong statement. So here what they are trying to say is trying to provide is they are giving the statement and they are giving the reason also for the statement what are they provided here. So here because of this, then our statement saying like a bird, white bird, because of because of this information is saying as a white bird. So it's simple. It's just trying to show you what is the information, what is the description is generated and based on what is the importance of out of complete image, which portion of image is giving weightages to the complete generated image. So I hope you are clear. Is it clear? Yeah, I will stop this point. Then we will start a coding session if you clear then. Okay. Yeah. That please respond that question the person asked. Okay then. Yeah. Okay. So yeah. So till now we saw about theoretical information and everything. So now we are moving forward and how to implement it. See, understanding we can get so many books and so many materials, but this theoretical hands-on sessions are very important. What I feel personally. So that's why please please put more attention. So if you are not understanding anything, please let me know. Even small things also, I will try to give the explanation. And okay, I'm going to stop. I'm going to stop allowing mute. I'm going to mute everyone. So yeah, if anyone have any doubts, please let me know through the chat. Okay. So okay, so I hope everyone is clear with our slides and understanding. By the end of the session, I'm going to give the slides to the public through link through the GitHub. So if you want whatever the concepts we are explaining in this session, that will be posted or published in a public GitHub account. So you can take from there. Okay, so no worry about the codes and all. So the codes are provided by the end of the session. So no worry about it. So first I'm trying to for your understanding, I'm trying to start with the emotion recognition. Then I'll go with our initial problem, Google Brains. Okay. So this okay. So yeah, our problem statement is clear. I hope everyone is clear with our problem statement. Our problem statement is very simple. We have a tweets and we have the Twitter having so many tweets. So what the Twitter is, what we are trying to do is, we take the training data set. The training data set is the existing feeds data set and with their respective emotions. Now what we are doing is out of all training data set and all, we are trying to make a project. That project in future, the project takes the tweet from the Twitter or from the user, then classifies and then figure out the emotion and then recognize the emotion from the tweet. So that is our project. Okay, so it is clear, I hope. So the emotions, now I'm considering only 6 kind of emotions. So okay. So for the project, I'm going to install. So basically, I'm going to give you the height. I just want to give you some. Okay, so whatever the problem, the basic, the standard structure of projects, I'm going to show you. So this is useful for everyone. So basically, even organization or data scientist or AI engineer, whatever the person they are, so they are using this structure. So I'm going to show you that structure first. Then I'm going to start my hands-on based on through that structure flow. Okay. Yeah. So these are the things. Yeah, see, okay. So, don't see, basically, I'm just taking a structure only. Don't see on XGBoost or something, whatever the words are there. But just see the structure. The first thing is we need to import the libraries. What is the first step? We need to import the libraries that are required for our project. Then second step is we need to import the data set. Okay, we need to import the data set. And third step is we need to visualize the data, means analyze the data set first. Third statement is we need to clean the data set, whether in real time the data set is completely unclean. So for that reason, we need to do the data cleaning. So for that reason, we need to do the data cleaning step. After data cleaning step, we need to do the data analysis as well as data pre-processing. That is the step number 4. Okay. Now after data analysis and data pre-processing, so we need to do the feature selection. So it's better to give in a notepad. So please everyone note this steps. Import the libraries is the first step, and import the data set. Import the data sets. Second step, then the third step is do the data cleaning. And fourth step is the data analysis. And fifth step is the data pre-processing. And sixth step is the feature selections. Basically, feature selection is a standard step. So normally in every scenario it is not required, but it is a standard step. And then we do the training and test split. And then here our models will come. Building a model or building like model or algorithm or whatever it is. So here that RNNs, LSTM, whatever the algorithm you have learned or whatever the model you learn, whatever the neural network or whether it is neural network or whatever it is. So comes here. This is the part. Now we start doing training. Now after training we do the prediction. Now after prediction we do the evaluation, performance evaluation and all. Evaluation or performance. So yeah, this is the steps. Basically, these are the standard steps in every data science project is going to we are going to consider. So yeah, let's just take a note. So I'm going to so now I'm going to go with the same flow. First, I'm going to import the libraries. So for that, I'm just so basically I'm using a Kaggle notebook. So Kaggle is a cloud platform where you can write your code and compile your code. So I'm using the Kaggle platform. Okay. So yeah. Yeah, I think we need a break. So actually, I forgot the break. So sorry. Yeah, I just want to know from audience. So means everyone requires a break. Means we can take if anyone means we need a break, small break. So I'm going to give a break for 10 minutes. So sorry for I just forgot the break. And see, this hands-on session is very important. So whatever you learn, if you are if you have any doubts, you can get through the internet or browsing. But coding session is not easy to get the answers from directly from internet. So okay, so please come back after your after 10 minutes, everyone.
Sir, can you please show the steps again, sir?
Okay.
Okay, sir. Thank you.
Basically, I just want to to make a standard for path. So that's why I just so I just give I just every time I follow these things.
Sir.
See, our theoretical knowledge comes always here only, but the rest of the things is very tough. So as a data scientist or as a AI engineer or as a researcher, the 70% of work is lies more on remaining tasks rather than building a model. Building a model is just a 20%. and remaining are 70%, and 10% is the debugging. 10% is like more on evaluation and production. So I will start at 11:48. Good morning, all. I hope everyone is written. I shall wait for 2 minutes. Actually, what my point is, if I have any time remaining after our hands-on session, I'll definitely try to give you understanding about autoencoder, because I already make a slides also regarding autoencoders, but because of time being, so let's see what goes. So my intention is like, if you understanding one concept also, you need to clear with theoretical understanding as well as implementation. That is my point actually. So for that reason, I'm fully focused on complete end-to-end implementation of each algorithm. So yeah. Shall we start? If anyone is if you have any time, then I'll definitely give the autoencoders understanding. And I'm going to put this slide in public mode only. If anyone want to learn more about it, just take a note, take that from them. Okay. Yeah. So let's start our session. Yeah. So please everyone note it down. So yeah, this is the standard project structure. So almost from last 2.5 years or last 3 years ago. So everyone is this is the basic and the standard structure of a project in learning or machine learning and artificial intelligence. So first thing is we need to import the libraries. We need to figure out the libraries which are required for our project, and we need to think about the dataset, import a dataset, which means collect the dataset or whatever ways or do. So finally, we need to import the dataset, and after collecting the dataset, we need to check the data cleaning, whether any unentered or any blanks or any zeros or something, any misinformation or anything is there. So we need to check the data cleaning stage. Then we are doing data analysis. So in this stage, we more focus on focus on data analysis, means what is the values, what is the count, what is the minimum value, what is the maximum value, what is the mean, median, summary, and everything we will consider what is the kind of data it is. So data pre-processing technique, which is the customized technique. So this technique is individual for each task. So based on the task, we are going to do the data pre-processing. So based on the task and based on the data set, so we are going to do the data pre-processing. Finally, through this data pre-processing, finally we make a data that is given to the model. Okay, so that is a thing. So after data pre-processing, we will select a feature selection. So feature selection, basically in feature selection, we need a domain expertization. For example, if you have a table structured data, so for example, if you wanted to measure, if you wanted to predict the price of house, if you want to predict the selling price of house, you need to have a parameters, right? What is the area, what is the land, what is the location, in which city it is presented. So there is so many parameters are there, and there are so many attributes are there. So the question in this feature selection is all about what parameters we need to consider, and what parameters we need to take into the consideration. So that things basically requires bit domain knowledge, or based on problem statement we need to have that kind of clarification we require. But the feature selection is also one of the steps. After doing a feature selection, then we are going to do for training and test split. So training and test split is a very standard and normal split, like a normal step where we need to split the complete data set into the three categories. One is training, testing and validation with respect to standard like respect to 70, 10 and 20 20 ratio, which means first 70 means a training, 10 means a validation, and last one is the testing. So this is the basic percentages of a complete data set. So we need a training data set of 70%, and validation data set of 10%, and test data set of 20%. So from these data sets, now we are going to now whatever we discuss in our slides, that step comes here. So basically this is the only single step. This learning algorithm is very, I feel, nothing until unless you are going to implement it on a complete project. So the learning algorithm is a very means only a single step, but we have so many other steps also. That is my point. So after building a model, then we are doing a training by using fit operation or something. Respect to operation, mostly fitting is a method we are using to train the model. So after training, then we are doing a prediction. After training a model and after successfully make a model, then we do the prediction on the test data set, or we do the prediction on a future value. The prediction can be two ways. One is basically a standard way is a test data set, and some sample feature data set, feature records, individual sample feature records, single records. Okay, so this is the prediction. So now the evaluation. So the evaluation is based on our loss and our loss function. So basically, if you consider our problem is a classification task, right? We need to figure out the emotion out of 6 emotions. It is morely on a classification task. So we need to take a measurements from that. So basically, loss here it is a cross entropy loss. So we need to, so our target is we need to get a minimum cross entropy loss. That is the evaluation matrix. So, and this is the like portion of steps, like building a model is only takes 20% of time in real time. In a overall project, building a model takes only 20%, and remaining steps like data loading, data cleaning, data analysis, data pre-processing, feature selection, and remaining all tasks takes 70% of time. This is very big work, I can say. Like this is very time consuming and very important. Making a model is very simple if you done the 70% of work. Then the 20% is evaluation and production. After doing evaluation, we need to put into the production site, production place, where our model is run for our business purpose. Production for our business purpose. Basically, from as a industry person, like I'm from, actually I forgot to tell you, I'm from DRDO, Young Scientist Lab. So I'm a AI researcher come scientist here in DRDO. So finally, whatever we develop, we need to place everything in a hardware. So that work is called as evaluation and production. Okay, so finally, these are the steps which is required for complete data science project. Okay, so I'm going to give this file also by the end of the session. Okay, so I hope everyone is clear with the standard structure of standard structure. So now we start our project. Okay, so this is our
whether we can get this file.
Yeah, sir. Everyone can get the file, sir, and not from Hyderabad. I'm from Hyderabad, but I'm from I'm a DRDO from Chennai. DRDO Young Scientist Lab from Chennai.
Sir, one quick question. So the project structure which you just showed us, so is it in TensorFlow JS?
Yeah, I mean, so see, TensorFlow is a library. So this is a complete flow. So here you can take a TensorFlow or you can take a PyTorch or whatever it is. So that is that comes under the libraries.
Okay. So I hope there won't be any libraries for MATLAB, correct?
MATLAB inside a MATLAB only you have, na? I use MATLAB sometimes. So inside a MATLAB only we have libraries for neural networks. Just check out the MATLAB documentation. You can definitely figure out MATLAB documentation libraries.
Yeah, please share your GitHub links with me.
Yeah, sure. For general purpose, but MATLAB is very specific. Most of the people are using Python for developing data science projects. So for that reason, I'm not considering MATLAB. So I just more focus on Python coding and as well as TensorFlow. But we can use PyTorch and all. So, but as of now, we are using TensorFlow with Python as a coding part. So this is the basic flow. So actually, I want to show you. This is my GitHub account. So by the end of the session, I'm going to submit all documents and all files here. So here, from here, you can get what are the coding file as well as slides as well as this note. Those two files can be shared after our session. So if I'm share now, then you will more focus on that things and this thing. So you will not focus more concentrate on the.
One confusion, sir. Excuse me, I want to interrupt you. Sir, like in MATLAB, there is a libraries like neural network, NN. I think so.
Yes.
That is ANN, and here it is TensorFlow and what you told. That one is equivalent. What exactly is?
Yeah, so sir, I will tell the same whatever your doubts you have. I am going to cover in the next slide. So I'm just give me some time. So then we will your doubts will be clarified. Okay. So here, so this is the flow and this is the library. So first I'm going to import the libraries here. So here so basically this is the Kaggle platform. This is a cloud platform. For that reason, I'm not going to install everything. So by default, Kaggle install most of the libraries. If any libraries is still not installed, then I'm going to install the libraries. Otherwise, I'm just directly import the library from Kaggle cloud environment. So in cloud environment itself, they already install all popular and almost all libraries. Only few libraries are not installed in Kaggle. So those libraries you need to install. Okay. So for that reason, I'm out of like TensorFlow, Keras, and MATLAB, Pandas, NumPy, and scikit-learn, and almost everything whatever I imported here is installed in Kaggle cloud environment. So only this NLP and datasets are not installed in Kaggle cloud environment. So that's the reason I'm just installing this. So yeah, in meanwhile, I'm going to tell you. Sure. So basically, basically this is my documentation folder. So here you can see. So first, so basically this is a Keras documentation, and I'm going to show you the TensorFlow documentation. So whatever the library I'm going to tell you, if you are not aware of it, just to go with the documentation, because we don't have more time to give a brief introduction or brief explanation for each individual library. But I can say one thing, just to go with the documentation that is available in their respective website. So documentation is enough to get a knowledge on the library. So I just suggest you. So that is the best approach to get a knowledge. So here in documentation itself, you can get a tutorials and guides. So here is the tutorial. So if you are a beginner, then they are classified into all categories. If you are beginner, basic ML, and how to load and pre-process the data. And so there are many ways there. This section is for beginners. This section for advanced. So here these are the libraries. So and there are so many resources are there. So just go with the resources if you are not aware of those libraries. So for example, for last time one person asked me about the pandas. So I'm just showing you pandas documentation, and I'm just giving you some short information about the pandas. So this is the library of pandas documentation. So pandas is very powerful and fast open source data visualization library. So basically, these pandas are useful to load the files like a CSV and Excel, and so many files we can load, and we can do the data with analysis and manipulation. So basically, this is the open source and top most data manipulation tool. So if you are not understanding the like codes or anything, so so click on the documentation, go with the documentation, like user documentation. So in user documentation, you can get everything in detail. So if you are not understanding, for example, I'm just saying, if I wanted to see the missing information, so how I see? So basically here, so see, basically for seeing missing information, this is a way. So like fill drop NA, like fill NA, ease NA means is there any nulls. So these are the ways. So if you want to, basically these are the sample codes and examples. If you wanted to know about the methods and their parameters and all, so here you can get it. So here, for example, here, so I wanted to see about missing information. I already told you. So here, this is the missing information handler. This is the method. So in missing information handler, you can see these are the ways to handle the missing information. Like find out how to detect the missing information by using this method. Data frames dot is NA, so which detect the missing information. So what I'm trying to, so I will reconnect the points. So don't worry. This is the one information. Okay. So now I move back to our code. So here we install all libraries required for us. So basically, okay. So here, here what I'm trying to do, I'm trying to import the libraries. So if the library is not present in Kaggle Cloud environment, I'm just use the pip install that library name. So if it is inside in the Kaggle Cloud environment, directly I imported. So I just took the TensorFlow. After that, I took the NumPy, then Pandas. This is for Word because our reads are in a Word format. So I'm just considering only Word library. So this is the visualization library, and this is MATLAB also a visualization library. Plot5 also a visualization library. This NLTK is a natural language toolkit library, which is used to convert the words to which is used during data pre-processing. Okay, then we have a TensorFlow Keras pre-processing techniques, and now we have for making a model, we need to get TensorFlow layers and models. So for that, LSTM and DenseNet dropout. For bidirectional, I am going to use a bidirectional layer. So these are the required libraries which are required for our entire project. So I'm just I downloaded my required library. So now what I'm going to do, I'm going to import the dataset here. So basically, this dataset is available in cloud. So that's the reason from this library. So load the dataset emotion. So this is the way to load the dataset which is available in cloud. Okay. Okay, now I'm going to load the dataset. Okay, so here I'm just I downloaded a dataset which is available open source. So I just successfully downloaded all dataset. Now what I'm trying to do after downloading dataset, I need to do the I need to do some data first as per the statement. So I need to do whether is there any out of complete dataset, is there any train dot is NAS dot sum. So which means I just try to see is there any nulls which is present inside my complete data set, but there is no nulls is present. So my data is completely cleaned. So now I'm going to do the data analysis. So for that, first I'm going to see my first 10 records of my data set. So here my data set is like this. So basically this is the label. Basically I just loaded a training data set. Basically most of the already everyone is know that training data set having X variable and true variable also. So here this is our training data set. Our training data set, a label is our true label, and text is text is our input, our tweet and our input. So label is our target variable, and this is the output. Okay. So for example, here I'm just reading top 10 records of my library using top 10. So I can say the thing. So if, see for example, so I just come with see what I'm trying to do here. I just try to load the data. After loading data, I'm going to do the data frames using my data set of a training data set. Using my training data set, I'm going to do the data frame. So okay, so that is stored as a train, and same thing, validation, testing, all are stored with respect to train, validation, testing. So now you can ask me, train.sana dot some what is that methods, what the words it is, and how to write, and what is my requirement, and why I write these questions. So that is your questions mostly. So further questions here you can see this is what I write. So data frame dot basically train is a data frame, right? So what I'm trying to figure out is my requirement is first requirement is I need to detect is there any missing information is there or not. So for that reason I'm going to call this method. So that is called as data frame dot na. So this will return the my missing information. So okay. So what I'm trying to say is, so basically whatever I used in my library or whatever I used in my project, so every project and every library and for every method there is some explanation and some information is there. If you are not understanding, go with that document API keys or document a library document, then you can get the information. Like this method is trying to do detect the missing values, return the boolean of size, like if it is NES are there, then it will detect and it will say there is NES. So here the sample examples also there. Okay, this is the way to use the libraries or way to use the methods. So that is my point here. So here you can see I'm just trying to so I just saw one line. So you can get the meaning out of it. So here you can see I'm grabbing a minute to post a field greedy wrong. So because it's a kind of like after reading the tweet as a human being, I can know whether this is a tweet with respect to anger, the feeling anger. But how a machine can understand and how a machine can label it as a anger, that is the point here. That is our project here. Okay. So and now I'm trying to do how many unique labels, means how many unique values are there. Basically we have 6 classes: sadness, anger, love, surprise, fear, and joy. These are the 6 classes. Okay. Okay, so now I just wanted to visualize. So I forgot to tell you here we need to do some visualization also. EDA, exploratory data analysis. In data analysis part itself, we need to do this thing to analyze the data with a visualization. It's called as exploratory data analysis. So what I'm trying to count is what is the counts and their respective lengths. Okay. So now I'm just for each emotion, how much of the length is there? How much of the length count? Like say for example, sadness is an emotion class. So the Twitter size of that emotion class is how much? How much of the Twitter size emotion classes? So here you can see that this is varies from here to here, like this. So this is a data visualization technique. So here I'm trying to visualize the data to understanding more about the data set. Okay. So here the joy tweets taking very length, means joy tweets are very long tweets and very lengthy tweets. So that is a point here. Okay. Okay. So now I'm going to do the distribution of labels. So here you can see so total counts in complete our data set for each class, how many counts are there, how many values, how much of count of tweets are there. That is a distribution of labels, which means joy tweets are more and sad tweets are second highest, and this is the visualization. So now I'm going to see the frequency of words. Frequency of words means inside whenever you do the tweeting, then the words we are like in chatting or somewhere. If you see so many words we are using, right? So like so many words like hi, how are you? I'm fine, I'm good, something. So it's like that. So that is about the frequency of words in a training data set. So here you can see this is the frequency. I means most of the times people are using I. So that's why I is very high frequency word. Frequency means in the complete data set, how many times these words are coming. That is called as frequency. The also complete, to also to, and feeling, ye, my, it, in. These are norm. So like more common words. So that's why they are coming very high. So here you can see feeling. Feel alone. The word alone is very rare. So this count is very less. Only 169 times only it came. Okay. So according to the graph, the most frequency include stop words such as I and to, etc. So further we are so here so that what we are target is, so those words the stop words doesn't give any information, means doesn't make doesn't give the more any weightages to the feeds. So that's why what we are trying to do, we are trying to remove those stop words. Okay, so yeah, so now what I'm trying to do, first I'm trying to tokenize the each tweet. So token basically in NLP task, basically our task, this is our task is NLP task, so which work with text data. So in NLP task, basically we need to basically follow the basic steps. Tokenizer, first point is the tokenizer. Tokenizer, then second one is padding. Then padding sequence. These are the standard steps we need to follow for NLP task. So that things only I'm going to cover here. Okay, so here first I'm going to do the tokenization. Then see the how the tokenization is. Tokenization is nothing but take each word and place in a bucket, something like that. I, comma, does, comma, feel, comma, who, humiliated, comma, something. So it's like each word is separated and placed as a token. Each word is taken as a token. So by the tokenization, we split each word point to the words. So tokenization is one of the key steps for NLP project. Okay. Now what I'm trying to do, I'm trying to remove the English stop words. Stop words basically doesn't give any information to the overall meaning of the sentence. So it doesn't give any information. So for that reason, I'm using this technique to remove the stop words. So so finally after stop word, it is like this. So I is removed. Only did not, feel, humiliated are the important words. So remaining remaining stop words are removed. So according to the 5 statement, you can absolutely achieve everything. So now I am doing, so this is laymanization, like padding. I already told you, like laymanization is a process of grouping words together, the different instance form of words, so that we can analyze as a single term. So basically, it is a technique which is used to get meaning. Means it is similar. After doing this, then we are using this laymanization, means grouping a word. If any words requires a group, then we can make as a group. That is a laymanization. Now what we are trying to do, we are trying to generate the tokens for each sequence. Okay. Now I'm just using word count. See, these are the high words which is you can see. Helpless, and these are the color and the strength of the word indicates the number of times they come. Okay. Now what I am trying to do, so I already told you tokenization is essential. So with this tokenization can be done. Okay. Now we need to do the text to sequence conversion. So after tokenization, we are doing padding conversion. So padding sequence conversion. So the padding sequence conversion is done. So then we are the tokens and their respective token of version. So yeah, this is the token versions, and here you can see non-token version and token version. So this is the final token version. Okay. Now I am doing padding. Padding is the final step which is required for any neural padding. Nothing but, see, for example, I have a very long sentence is there. and after at the same time I have a very small sentence also there. But how I can get a standard structure which containing everything in a stable structure? So for that reason, so see here this is the big structure. So the big structure is having this much of length. So here you can see. So but our present sentence having only 3 words. So how we mapped is we need to use the padding, which the technique which is added zeros in the remaining places with respect to the longest sequence. So basically this is the longest sequence. What we are trying to do is we are trying to make a padding. The padding is added to the sentences. So the sentences remaining we are just giving the zeros, and only this whatever the original sentence is placed, this is only placed like this. So finally this is the concept of padding. Now our step comes. So now I am going to, so till now whatever we do, so with respect to like whatever I mentioned here, I imported libraries, check the data cleaning, data analysis also I did, and visualization also I did, data pre-processing. The data pre-processing, nothing but here in data pre-processing, these are the steps required in data pre-processing in NLP. And now there is no concept of feature selection because it is not a predictive analysis. It is like a NLP task. So there is no feature selection. Now we do the training and test bit. So in training and test bit is itself we did because we loaded from data set, and there itself we took the data set individually, train, test, and validation. So there is not required of training, testing, split. So now our step is building a model and algorithm. So now we are at this point, okay? And if you are not understanding with the syntax of programming, just like I am going to give the code and try it. If you are not understanding, just make a Google it, and you can get some information. So, but just see the flow and just assume based on whatever I said. Just take that as a note as of now. Okay, now I make a model. So this is my model and this is my architecture. So here you can see first in my model, first I'm going to take I'm taking the words. So I'm just converting the words as embeddings. After converting, I'm doing global average pooling 1D. So after this, I'm going to add three stack layers of three hidden stack layers of bidirectional layers. So finally so here this is my network summary. So this is the layers. First one is the embedding layer. So basically this is the NLP task, right? So in NLP task we need first layer should be embedding, which is used to get the embeddings of each word or each sentences. So after getting embeddings, then we are doing global average pooling 1D. So this is a kind of random experiment adding layer. So now what I'm trying to do, now I'm going to do the LSTM, bidirectional LSTM. This is the basic syntax to add a bidirectional LSTM basically. So here the layers dot bidirectional. So here if you want, I'm going to show you. Basically I wrote in a Keras, means I took from Keras. Keras is a part of TensorFlow, so don't confuse that. So actually this is the Keras API. So in this API, I'm going to read the layers. In these layers, I'm going to take this RNNs. Yeah, here you can see this is the recurrent layer. In recurrent layer, LSTM is there, GRU is there, simple RNN is there, time distributed layer is there, and bidirectional layer is there. So for bidirectional LSTM, I need to use bidirectional layer along with LSTM. Okay, that thing I did it here. I added bidirectional along with the LSTM. So this is the way to cover the bidirectional LSTM. But I just want a good accuracy. That's purpose I am added 3 more bidirectional LSTM. Basically, this number of adding layers and number of neurons in each layer and the activation function is all about a random experiment. So there is no straightforward technique or approaches. There is no. So to say this many units can give you best accuracy here, and this activation function give you best accuracy. There is no straight and forward answer. So you need to get to know by using a random experiment. So finally, this is my model. So here I am using this is my final layer with the 6 as a number of hidden layers. So I just added 3 LSTM bidirectional LSTM layer with a dropout. Dropout is useful to overcome the overfit problem. So after that, I'm going to, this is my output, output. So here, my number of classes are 6. I'm going to use activation as a softmax. And the loss is, here is a soft parse categorical cross entropy, is a kind of cross entropy. Parse indicates that we are not using one-head encoder or categorical way. So we directly give the values. So that's why it is a parse encoding, parse categorical encoding. Optimizer, we are using Adam optimizer, and metrics is accuracy. Accuracy, already told you, metrics is accuracy. Finally, this is a summary about our matrix. So now what I'm trying to do, I'm just do some pre-processing and labeling before going to the model. So here, this is our labels. Joy is, so what I am trying to do is, we're trying to get a maps of the labels. So what is trying to, basically in a static data set, our labels are mentioned in the strings. So we just replace the strings with respect based on this dictionary. So sadness indicates 0, joy indicates 1, love indicates 2, something like this. So what we're trying to do is, we're just trying to replace strings with fixed numbers with respect to each class. Okay, so here you can see label 0, 0, 3, 2, something like this. Okay, so now what I'm trying to do, I'm just using earlier stopping technique to stop the model with whenever it having good model. So now I'm going to run my training, my network. So I'm going to run my network. So I'm just given 100 epochs. So basically 100 epochs are required. Means a number of epochs as a random experiment. There is no fixed rule to give. So actually it takes so much of time. So for that reason, I am just stopped my training, and instead of 100, I am going to give only 10 because I wanted to show the results. So that's why I'm not giving. So if I give a 10, then the model is not getting very good accuracy. It's getting accuracy, but still it can able to get more accuracy. But ideally, we must be give the epochs based on our learning. But in this hands-on session, for time purpose, we don't have more time, so that purpose, and we need to be ideal if you give more time, more epochs. So that for that reason, I'm just, as of now, I'm just taking 10. So it's taking 4 minutes to complete the execution. Means 2 to 3 minutes to complete the execution. So here we are doing training. So with model.fit, and this is our training data set, and this is our training labels, true labels, and this is the number of epochs, and this is our validation data set. This is our validation data set, and this is a validation label. And using a back calls. So with earlier stopping, I hope everyone know. Earlier stopping, nothing but out of training 10 epochs, then it will figure out a best epoch. When the model is not training, the model is going for down performance or some problem, then it will stop there. So that is concept is called as earlier stopping. So it takes some time, so I need to wait for some time. Actually, I don't know why the time is consumed, but it's taking very, the session is taking very time, so I'm not, I think we already come to, we have only 5 minutes left. So I think we don't have more time to cover the Google Brains AI project. I'm really sorry if you have any time remains, then we will cover that project also. But the main core idea is same. So, but my only intention is first I need to give the theoretical understanding of an algorithm, then practical hands-on. So for that, I already told you I already show you complete structure. So that's why the same structure will followed in same other project also. So basically, I followed that structure only. So yeah, if you are missed, then it's okay. Another next sessions we will go into cover in the next upcoming FDPs. But the theory is hands-on. I just try to cover these things. This is my first. So here I am just waiting for training. Okay. Natural Language Toolkit, NLTK means. Okay. Oh, someone answered. Oh, yeah. Okay. Thank you. Epochs means learning rate. Epochs means not a learning rate. Learning rate is something different, and epochs is different.
Epochs means one iteration, one complete iteration that covers every point of dataset, training dataset, which learn every point of training dataset.
This NLTK is also library. It is of Python or?
Yeah, it is a library only. I will show you that thing also. NLTK is developed by Microsoft team. So basically, they follow. I mean, they provided in different ways. If you mostly they provided in Python in a standard way, but they will provide some libraries are still present in C++, and some libraries are present in R programming also. But it's up to their wish. So up to that developers wish to provide. So basically, NLK is this is the NLTK. So this is a very popular and well-known library for NLP projects. So download NLTK and so basically, I already told you it having some data pre-processing techniques. So those techniques are very useful. That's why NLTK, the people are using NLTK to using that library. We are doing some data pre-processing. So that during data pre-processing, NLK is very useful. Okay. So actually, you can observe this. My original model accuracy is around 92%, but due to the number of epochs is 10, so now I'm able to get only 87.40. But I don't want to put more time on training, ideal time on training. So that reason I'm not put. So here this is the plots. So here you can see this is with respect to training loss and validation loss. So this blue line indicates a training loss, and orange line indicates a validation loss. So here the training loss is still going down, and our validation loss also going down. So it seems to be good. So our model is not in a overfit or underfit. Our model is good. But if you want to get some more very good model, then you can give more number of epochs and do the hyperparameter tuning. So hyperparameter tuning helps you to get a good accuracy. You get some accuracy, but getting a very good accuracy requires hyperparameter tuning, basically. Okay. So yeah, now, so finally, our step here, our training step is done. So after our training, I just plot I just see whether our model is overfit or underfit. I think it is still, I mean, because of number of less epochs, it can still learn. But due to the time reason, I'm not putting more ideal training time. So yeah, here I'm going to check whether a model is underfit or overfit. So you need to check that. After checking that, if you feel the model is good, then go for the predictions. So now I'm going to take, first I need to prepare my data set also. Same thing, whatever the data preparation techniques I used for training data set, I need to use the same techniques for test data set also. So here I'm doing this. Okay, so after doing the steps, I'm going to evaluate my performance with my test data set. So now I'm going to do the predictions. So basically, this is my test data set. Okay. In test data set also, I have. Okay, yeah. So now till now we completed about the training, and now we discuss about the testing, means prediction. So before going to the prediction, so first thing you need to consider one thing. For prediction time, we are going to use a test data set, right? So whenever you want to use a test data set, the test data set also needs to go with the same step that we implemented in a training data set. That data pre-processing steps, whatever we use use during the training time. So that steps needs to be done must be done for the training data set. So the same first thing I'm doing tokenization, removing stop words, then I'm doing lamentation, then cleaning. After that, I'm going to use the tokenizer, then use a padding sequence. So finally, I got this. So now I'm going to get what I'm trying to do. Now I'm going to see the test true values. So I just place the true values with this. Now I'm doing model dot evaluate. So model dot evaluate gives the complete evaluation. Like now I'm able to get a accuracy of 0.87, but its accuracy is 92 plus something, because we this model can learn. So if you give epochs of 10, 100, then it will give the accuracy of 92, but we are giving 10, so it's giving 87. Okay. So epochs also one of the parameter hyperparameter tuning. Okay. So finally we did prediction also. So we did pre-processing for prediction. After pre-processing prediction, then we do the evaluation. So this is the evaluation. Evaluation nothing but we predict the value, and after predicting this, again we compare with our true test values. Then we can say how much of percentage or how much of accuracy is there for our model. Okay. Now what I'm trying to do, I'm trying to predict only the individual codes. Okay. One individual flow. So here you can see. So now the text data set, I am just giving you one example. Okay. The example is here. This is our test data set. I just pick a one test data set here. So I'm just here. So I'm just calling one. So here I just wrote a method called make a prediction. In this make a prediction. So basically this method, why I write a make a prediction method means whatever you give to the model, whatever the model you need to give to the model, that input should be follow the same steps that we did during a training data set. So for that reason, in the future, you directly give that sentence. You no need to take care about pre-processing and all. So you directly give the sentence to the model, and you need to predict the output. So what happens whenever you send the direct input, feature input, then this is going to happen. So make a prediction. So I wrote one method. So here it takes the direct input, whatever you send in feature. So then it make as a string and use a tokenizer. Same steps, whatever you follow, then it do the steps. And finally, if your output is 0, then the emotion is called as sadness. If it is 1, it is joy. 2, love. 3, anger. 4, fear. Else means final. If it is 5, it is surprise. So finally, this is our final output, what we are going to predict. Okay. So now I'm going to run on a one record. So here I'm just pick one record from test data set. The record is like this. I feel could have been avoided with some badge markers or lines. I was very annoyed at that point. Okay. So this is the tweet which is provided by the user. So from this tweet, we can predict actually this is the actual emotion, because we already have a test data set. We have both in test data set, we already have a true values also. So this is the true, with the true values, this text emotion is anger. So now see our prediction. So the predicted emotion is also anger. So our model is working very fine. So now take a second sentence. I never told my boyfriend or his parents, and I do remember feeling embarrassed and may even a little ashamed. So which means sadness. Okay. So the actual emotion is sadness, and the predicted emotion is also sadness. So now I'm just making some confusion matrix on a test data set. How many times it is predicted. So for example, 0 indicates something sad, right? Sadness, right? So basically, out of complete sadness, so out of, for example, it is total somewhere around 550. In out of 550, it is correctly predicted 532 times. It is correctly predicted. So in 18 times it's predicted, instead of sadness, it's predicted as a 1. So 4, 17 something. So this is a confusion matrix to evaluate our performance. Okay. So now this is very interesting. So having fun with the model. So what I'm trying to do is I'm trying to write my own tweets. If I am a user to the Twitter, so I'm just trying to put some tweets randomly. So now I want to see the emotion. So, and here, this original emotion we don't have, but as a human being, we can know whether what kind of emotion it is. Because we can, as a human being, we can realize. So, if anyone want to give any give any tweet, so just make give the tweet through the chat window. I will put the tweet and I will tell you what kind of emotion it is. So you can get complete understanding on this. Like I'm telling you, I'm very happy. I'm very happy for the session. Something like that. I'm feeling very happy for neural network. Something like this I'm writing. So now see what kind of. I think it should be joyful or something joyful or happy or something like this. Become joy. I said yeah, it is joy because I use the keywords happy, feeling. So those are the keywords which influence the emotions. As a human beings, see if I feel bad, if you give bad, then the emotion will change. I feel very bad for neural network. Probably sadness will come. Yeah, this is a tweet, and we can figure out the emotion based on the words only. As a human beings, also based on the words only, we recognize our brain will recognize the emotion, right? So similarly, in model also it is the same. Okay, so I hope everyone is clear. Just a second. So I'm just allowing everyone to ask any doubts. So it is already in. So still, if anyone have any doubt or something, or I learned something new today. Okay, I'm giving this as a sentence. Let's see. But as a human beings, we can say sometimes some sarcastic sentences are there. So many ways are there, but still, most of the sentences having proper meanings and all. Like it is not.
So this one is not.
Actually, I'm trying to take one of participants in the one Twitter, like one message having.
I didn't keep any standard.
This is a one kind of tweet. So I'm just treating that as a tweet, one kind of note. So now I'm going to place the tweet. So yeah, I learned new thing, something new today. So this is the tweet. One of the participant is provided. So I'm just running the tweet. Sadness. So
Sir, how it has identified as sadness? Thing is, we don't have any standard terms here.
Yeah, basically, I learn, if you give any, if you give any good words, like I feel good, I learn good things. You see this, then it will become based on the words only, not if you give the words meaningful, then only it will give the approximate based on words.
Words.
If you give the
what if the sentence, the word good in the sentence was changed to interesting, sir?
Yeah, so because see, basically, if you say something without any words or anything, so even as a human being also not understand without incomplete sentences.
Sir, if we run more epochs, then it might predict correctly.
Yeah, that is true basically. But I already tell you, see, it taking so much of time. So that's the reason I'm not just taking only 10 epochs, just the 10 epochs. You can run in previous. I already, if you see while editing, actually it is 100. So if you give 100 epochs, then it is definitely gives more accurate results, better than this. Means it able to run each word and their weights basically. Based on each word, whatever the word you are placing there, based on the word and the word weightage, then the emotion will recognize. Okay, so I learned that something.
We say just nice or interesting, very good or something like that. One word or two words statement, sir.
Yeah. Okay.
Will it predict correctly, sir?
Correctly. See, if you see, for example, you are working in one office. and you in the morning, just I'm giving a scenario. You are working in one office, and you are going to the office, and you have one colleague is there, and with your colleague, you say I'm happy. Simply I'm happy without anything. Just you are saying I'm happy. What your colleague is recognize the feeling. Then we will see. I'm happy or I'm bad or I'm not good or something. So I'm happy. I am happy. I'm just making I happy or I am happy. So so this is a sentence you given to your colleague whenever you go to the office or something, a scenario. So then what your colleague is predict their emotion. What is going to is predicted that he's happy means he figure out the emotion of joy from your sentence. If you say I'm bad, I'm feeling bad or I'm bad something or not good or something, not good or something.
Just to confuse this model, for example, if I say I have no feeling,
I have no feeling.
So just type it out, sir.
Yeah, basically
what it shows.
See, basically neural network is all about giving I have no feeling. Yeah, whatever the training, if the words are present in the data set, the words whatever the present in the data set, that learning and that things only it is able to recognize. If this kinds of scenario or this kinds of pattern is not figured out in a training data set, even neural network also not able to learn. That is the main disadvantage with neural network.
Yes.
Yeah, but still, if you run with more epochs or more things, then you can get a more approximate answers. So here also you can see. So here you can see out of in test data set, out of 600 and something, so 650 times it is showing it is predicted character. So there is a more possibilities is there. If you confuse, even you can confuse your even you can with our words, we can confuse the human beings also with our words. So that is happen basically. But whatever you give as a training data, whatever the information or how much of knowledge you are giving to the model during the training time, that can be very useful while predicting. That is the only simple thing.
Supposing in the from the tweet, there is also emotis. For example, it picks up. Suppose I give the statement or the tweet along with the emotives also or the similes. Then it can combine. This model can combine both that image and as well as the text. The combination can be more accurate, no?
Yeah, that is true, but that kind of work is still now even Google also not did. So if you search recently, Google added a new feature. If you observe in Google, in YouTube especially, if you observe in YouTube, if you in a comment section, in a video, in a comment section, if you type something in a native language, then it will translate it into the English. Correct.
That's true. Yes.
But if you give emotion or emotion symbols or something emojis, then even the translator also not translate, right?
Yes, sir.
It is a still problem.
Okay. Maybe they will develop.
Yeah, that because see, as a human beings can recognize the emotions, but machines and the representation is matters. Representation and pattern matters for machine. So this all about the pattern learning. The neural network is all about the pattern learning and representation learning only. So it try to learn the representation and it tries to learn the patterns. So say something like if in a prediction mission, if you see in a mails, if you see in a mails, if you write something, then they are recommended something because they based on their data sets and based on they have so many similar sentences are there. So based on the similar sentences, if you type a word thanks, if you print a thanks, then the next statement is you. If you print I'm looking for, and then I am looking something, then to hear back from you in a mail especially. So it's all about a NLP task. So still the work is going on. So it's like this only.
Thank you, sir. Thank you.
Yeah, I'm really sorry for not covering the Google Brains project. So that project also very similar with the same project. So yeah, if you want, then I will within 15 minutes I will just cover with a with some speed. Same
Hello,
problem.
sir.
Yeah, hello.
Sir, I have one doubt. Can we write question also and it will show emotion?
Yeah, sure.
Okay. So can you please show any example?
Give me in the text chart window, then I will place here and I will.
Yes, sir. Yes, sir.
Yeah. Basically, so basically the problem is, this is a chart. Yes, please kindly cover the Google project. So this is our your statement, or you mentioned a statement or not?
So you mentioned the other case study is there, right, with respect to the Google one. So if you take 15 Google Brain ventilator prediction.
Yeah.
That one.
Yeah, but one participant asked about some sentence classification, so that's what I'm waiting. So okay, this
I've
is a
typed.
sentence. How was the day?
Yes,
How
sir.
was your day?
Yes.
Yeah. See, if you see how was your day, what you found feeling as a person, means just I'm asking normally.
Yes, sir. Good. I mean, feeling would be good if.
No, that is answer.
Yes.
I'm not asking answer. What is the feeling from that sentence? But as a human being, what
Yes.
feeling it gives you? See, this is a question basically. But what that
Yes.
feeling
Question.
gives you? Just I don't know, but how neural network is going to give you? I don't know. Yeah.
Okay.
Yeah.
It's
This is
just
the.
a greeting, probably joy. Yeah.
Yeah. Yeah. That is the thing. Basically,
We didn't add a question mark there, right?
you can add, but question marks are removed in stop words. Anyway.
Okay. Okay.
So that's are not allowed to train during training.
Okay. So it joy. Okay.
So because this pattern itself in the question, so I hope everyone is understand. So I need to cover the Google Brains project also. Yeah, thank you for. We don't have a time for that.
Yes, sir. Thank you.
Yeah, I'm just
Yes, sir.
moving project. Okay. Yeah. Okay. So I will spend the next 15 minutes on Google Brains project. So yeah, please mute everyone. Yeah, I'm some noise is coming now. Please mute everyone. So I'm not able to see mute all. So I think that admin access. Yeah, I'm trying to mute. There is no option. I think I'm not in host, so that's why I'm not able to. Yeah, thank you, ma'am, for muting. Okay, I will continue. That is not stop.
Please let us be more disciplined.
Yeah, sir. That is called as self-discipline. So if you have a proper self-discipline only, then you can get good things and good places. Without self-discipline, even you have how much of knowledge, it doesn't matter. Okay, so we will discuss about, we will have a short, some good discussion about the Relevance project. So in this, actually this is a project, still this project is going on. So I'm trying to be in a top 100, means a top 1 percentile. So presently my score is somewhere around top 5. So I need to be in a top 1. So I'm just showing you the solution, what I tried initially. So because it's basically it's a very huge competition, it takes so much of things. So I'm not make you more trouble. So I'm just giving you very high level of understanding. So that is useful as of now, because if I go very down, then it is difficulty for you. So that's why I'm taking a first version code here. here what I'm trying to do here, same thing. First I'm importing a libraries. So here I'm more focused on scikit-learn, TensorFlow, Pandas only. Those are the three major libraries I'm use. NumPy. Those are the four major libraries I use. So first I'm importing a libraries. Now I'm loading my datasets. Basically in Google, in Kaggle, in competitions, they are provided a datasets. So these are the datasets they are provided in input. So these are the datasets. This is the training dataset, and this is the test dataset. And this is, so is my voice is clear?
Sir.
It's clear.
Yeah, okay. So yeah, these are those data sets are provided by Google only, Google and Kaggle competition. So here first I am going to import the libraries what are required for me, and after that I am loading my libraries. So basically they are provided in form of CSV files. So due to the reason I am using Pandas to read the CSV files. Now I am going to so this after reading, then I am doing some standard data analysis. So first thing I'm going to check, is there any null there inside? Wait, who is talking here? I think he's muted, huh? That is not a TV, man. That they are playing intentionally. Okay, so just leave the top points. It's not a thing. So here, what I'm trying to do is just I'm loading a libraries, and after loading a libraries, now I'm trying to load my datasets, read CSV from Pandas. So after this, I'm going to do my Actually, and one more interesting thing is for this project, we need TPU support. So for that reason, we need to wait for a very long time. So I'm just canceling the TPU support because we need to wait for a long time to get a TPU support. Because these are the last 5 days. So almost throughout the world, so many people are working on this project. So it is not easy to get a free TPU support accelerator. So that's why I make a accelerator to none. Okay, so now again I started. Means accelerator is nothing but like about GPU and TPU. It's all about running your code with GPU and TPU. So previously I added a TPU support to run a code with the TPU support. But due to the not availability, so I'm just remake it as a none. So nothing is there. Okay, so now first I load the libraries. Now I'm going to load my datasets which are already provided. These datasets are provided by Google Brains on Kaggle platform. So now I'm loading the things. Okay, so now I just started data analysis here. So this data analysis and gives the information about is there any nulls in the complete dataset. There is no nulls in the complete dataset. So I just the data is cleaned. So after checking the data is cleaned or not, then you go for analysis. So in analysis, first you need to see the info. In info you can get how many records are there. 60 lakhs records are there. Literally there are 60 lakhs. 10036 60 lakhs records are there, and these are the columns ID so here you can see. So this is the CSV file they provided. So what the CSV file is, the first one is the ID, and second one is a breathing ID, and third one is some parameter with respect to lungs. And R also one parameter, and C also one parameter with respect to rhyme. And this is a timestamp. So these are the timestamps. Each timestamp they are giving, and they are giving in and out, and they are giving pressure. Pressure is our final target value. So we need to predict. We need to develop a model that predict the pressure for every timestamp. Okay, that is our problem statement here. So this is the training data set. So here from this data set, I'm going to see top 5 records. After seeing top 5 records, I'm going to see what is the column names and what is the data types of these column names. So now understand everything is clear. So we have a complete cleaned data set, and we have a 8 columns in training data set and 7 columns in test data set, and data types most all are on integers only. So that information we got. So now I'm going to check the test data set. So here you can see only the pressure column is removed from test data set, because from test we need to predict the pressure. So that's the reason we have take this test data set, and we need to predict the pressure column as a target variable. We need to predict that column. So this is a test data set, and you need to see the information about the test data set. Here we have the same columns except pressure column. So all remaining columns are same, and data types also same, but we have a 40 lakhs of records are there for test data set also, in test data set also. Okay, so now I'm going to use the train.describe, which gives the statistical information about the data set. So here we can see the count. Here we can see the mean, standard deviation, and minimum value and maximum value, and 25, 50, 75. Basically, these things are required whenever you start modeling. After modeling, you get some accuracy. After getting accuracy, you can again come back and see why I'm still getting this accuracy, how to modify all the things. So during that time, this information is useful. Okay. Now, so yeah, so I will take a questions after this all complete session. Okay, so now what I'm trying to do, so basically I made this is the data pre-processing. So this deep pre-processing, they suggested based on their paper. So I did this pre-processing based suggestion provided by the paper in Google in the competition. So just don't think about this data pre-processing. Just think like some pre-processing he did it, and we are doing some pre-processing. That's it. What is that and how we did it? Just not take consider about these things. Just read. We have we need to do some pre-processing before getting to the neural networks. So that is a target here. So after doing pre-processing, I'm going to do the feature selection. So I'm going to pick the features and drop the features which are not having more importance. So these things I already I know, because that's why I okay. So some error came. Okay, I need to run again. Actually, this is my first version of my code. My latest version of code is very huge, so I don't want to that will make you more confusion. So that's why I'm not showing that version. Okay, so what? So basically, So I did a data pre-processing. So what exactly in data pre-processing? As of now, don't think about it. Just remember, just to take a note of. I'm doing data pre-processing. That's it. So after doing data pre-processing, again I just do the feature selection, because I added so many features inside my complete training data set. I added this all features. So out of all features, what are the important features and what are the features which are not important? So I'm going to drop those features. Here you can see. So pressure is what we need to predict in a training data set. ID is not required. Breathing ID is not required. And these many columns remaining IDs are not. These columns are not required. So that reason I'm just removing those columns. So it is not required. So after doing data selection, I just need to transform the fit transform to get a final pre-processing data. So finally, I got a training data set and test data set. So after getting a training data set and test data set, I develop a model with a KV strategy. So KV strategy. So this KV strategy is a bit complicated. So I don't know whether you all are able to understand or not. So I'll just try to give you. But after making a data set, like cross validation strategy, most of the people knows the cross validation strategy. If you don't know, it is something like, see, in training and test split, if you take a directly training and test split, there is nothing is there. Directly you just static means you pick one thing and you make as a training and test split. But CV is something what we are trying to do. We're trying to make a complete training data set into the 5 pieces. So what we are trying to do is for five pieces, we are one time we take first 1 to 4 and 5th is a test validation piece, and second time we make a 1 2 to 5 and make a 1 as a validation piece. So using that technique, we can get a complete. We can visit and we can get a complete knowledge of each point. So that is called as KV, like a cross, like K-fold techniques. So I'm using KV fold CV techniques. So for the CV techniques, I'm using number of splits. For training purpose, I'm using for hands-on, for session purpose, I'm using 2, but in real time, I'm using 10 because I need to get a more splits and go to each split. So after splitting a dataset, I'm going to get a X train and a Y train and X validation and Y validation. From X train and validation, again I'm giving same whatever model you saw in that only same similar kind of model I used in basic version. So this is the model. This is my first model I use for the competition. So this is the same model, like I already explained you the information regarding the model. And I compile the model with Adam as an optimizer and loss MSE because in this competition they mentioned the loss is MSE. So for that reason I'm mentioned the loss is equal to MSE. And I use the schedulers because I need to learn with scheduling that gives you more accuracy and good learning. So that's why I'm using scheduler, callback scheduler. And finally I do the training the model using fit. So again, at the same time, for each fold, I'm using prediction and make a prediction, and I do the prediction on test data set and make appending that value. After doing all the things, I'm going to normalize the thing, mean the final prediction of pressure, and converted those values to the submission file and submitted those files to the competition, and I can get accuracy. So this is the standard and very standard and basic flow in this competition. I hope everyone is clear. If you are not clear, just I will submit the code and you will try the code. So that is from my side. So if still anyone have any doubts, please let me know. So probably our session, we already move 40 minutes. So sorry for that, for extra 40 minutes of time. Yeah. Yeah, one thing for sure, I'm going to assure you, like whatever we discuss, the slides and the note and the code, everything I'm going to share in my my GitHub account because I need to do some. Still, I need to do some every time. Whenever I give the session, I'll upload it here. So you just take give a upload it here with the dates and all. So if anyone interested, just to take that notes from here. So I'm going to upload everything, even PPTs and also everything I will upload. That for sure. So and after uploading, I will intimate through that organizers are intimated you through the WhatsApp in using with the links and all. Okay. Yeah. Thank you everyone. Our session is completed. I hope everyone is enjoyed the session. Thank you. Sorry for the disturbances which has happened between. And I request the audience to be supportive to the presenters. That is helpful. Yeah. Thank you. If you like, I just share my email address. If you have any doubts or any ideas or any problems, just send me or discuss with me through mails. So I will encourage everyone to use the mail only. I use mail mostly. So this is, I just send my mail ID through chat to everyone. So if anyone interested, like anyone have doubts or anything, just contact me through mails. Okay. Yeah, thanks. I think my mail ID came. Yeah, I just posted my mail ID. So take my mail ID if you everyone want. I will note it here also. Yeah. So I'm going to close the section. So this is my mail ID. If you have any research problem or research idea or research thing, so then you can contact me or you can submit your information here, and I will definitely reply back with my suggestions and with my knowledge, based on my knowledge. Okay, so thank you everyone. Yeah, I'm going to stop my sharing and I'm going to stop the video and all. Yeah, thank you. So I'm going to drop, and yeah, I just ask take the session, give the session to the organizer.